Hello, everybody, and welcome to week 2 of C# 102. I'll be here. I'm Nelson, and there is Gavin here as well.
Hello.
Hey. Okay, so this week we are going to be continuing basically the week 1 syllabus. We're going to be talking about interfaces, we're going to be talking about some of the BCL, and we're going to be talking a little bit about the homework for this course. So this course, I really wanted to do something fun with the homework, and so I came up with the idea, or more appropriately stole the idea from XNA 101, to do a text-based RPG as the homework. So we're going to be building pieces of the text-based RPG throughout the weeks of this course. So I want to point out that we are going to be building components of the system, but I want to stress the fact that just because we complete a particular component of the system doesn't mean it can't change. I really want people to be free to implement the system in a way that they feel comfortable with, because, I mean, really that's the best way to learn. I'm not going to be enforcing a lot of architectural constraints on the system that people come up with. I really want people to actually dive in and think about it themselves, although there will be a lot of guidance along the way.
And this is something that happens in the real world all the time.
Yeah.
You know, the clients are never happy.
Mm-hmm.
They will always come back and say, oh, actually, can you do this again, but twice the size in purple and display it in Chinese?
Yeah. And so we're going to be building this sort of piecemeal, but I really want to stress the fact that when working on the homework for week 1, or week 2 now, and the rest of the weeks, don't get locked up in, or don't worry about having to write the code only once. Code is a very mutable thing that changes a lot, especially during development, and especially during smaller projects such as this. So, yeah. Week 1 was not related to the text-based game. It was just practice, just getting some people more comfortable with the idea of class hierarchies.
And in actual fact, because obviously what was mostly covered in week 1 was the concept of abstracts and inheritance, and we are going to start, I presume, start off by talking about a better way of doing things, really.
Yeah. And so we had a great open office hours earlier today, but I do, for people who missed that, I do want to continue week 1 and ask if anybody has any more questions about what we covered. So questions about abstract, virtual, class hierarchies, stuff like that.
Yeah, specifically in the inheritance-related material that we covered.
Yeah.
Because what we're about to show you is slightly different and looks confusingly similar.
Right, and I really want people to get caught up with the idea of abstract and virtual, because that, like Gavin said, that leads right into what we're about to be covering next. Okay, I'm lost when it comes to setting up properties. Why the get and set? Well, a property is, in essence, one or two methods. So, for example, if we have a person class, and he has a private string name field. Now, this is a field. This is data that every object instantiated from the person class will contain. However, it is not good programming practice to allow other people to edit this field directly. We don't want anybody but the person class itself orchestrating, making changes to its internal data. It's a very, very, very important object-oriented principle that classes own the data that they contain, and they are the arbiters as to how that data gets modified and how it gets accessed. So that's why we have this private access modifier right here. We're specifying that this field is indeed private, which means we can't access it directly. So if I say var person equals new person, I can't say person.name equals Nelson. That's impossible. And it's impossible because of the protection level of the field. I've annotated this field with a private access modifier. Now, I could certainly make it public. Now, that's legal C#, but it isn't very good design because we're breaking the principle of encapsulation. We're really getting away from the core of object-oriented programming by allowing others to mutate this data. So what do we do? Well, the first thing that could come to mind would be doing what we would do in a language that doesn't support properties, such as C++. We would make what are called accessor methods. So we would say public string getName and public void setName. And so now we have controlled the access to this data. The person who's invoking methods on the person class, or on person objects rather, doesn't know where the name is gotten from, doesn't know the direct data that is being accessed when we invoke getName. So as a result, we can perform any sort of computation that we want to come up with that result, which gives us a lot of flexibility. The same is true for setName. We can enforce invariance about how names should be formatted, and in addition, completely reject this name altogether by throwing an exception. So now that we've done that, we can invoke the setName method and say, we want to set the name to Nelson. And then we want to print the name. So let's go, name is person.getName. And we get name.
And the key thing being that now, this way round, it is actually, rather than telling the directly affecting the name, you're telling the person to set their own name, as opposed to setting it for them.
Yeah,
you're saying, hey, your name is now this.
Yeah, and that's exactly what's going on. Really, we're working under a contract. We're working under a communication protocol with this object and allowing it to perform any computation it sees fit. Which the computation for setting the name is irrelevant to the caller, because we want to encapsulate that functionality inside of the actual method that's invoked.
And so, Ramon just said, why in OOP is that so important? Well, just imagine if rather than that being a name, that was, say, your salary. You wouldn't want other people being able to access how much you get paid. But you could, if somebody said to you, all right, now you're getting paid this much, and then you could agree to it and set it like that. But equally, I mean, this is the other thing with properties, is you can have a little bit of code in there just to check whether you're actually doing something you're allowed to do.
Right. Yeah, and the OOP, remember how I defined OOP in the last week? I defined OOP as basically building code using objects. And what's an object? An object is an entity in the system that has complex logic and data associated with it as behavior and has state. And OOP is all about the relationship between these objects, how these different objects interact with each other. And one of the fundamental things about OOP is that the objects are responsible for their data. They are responsible for maintaining the integrity of their data. This is vital. This increases the reusability of a particular class. It actually speaks a language to other developers indicating how a particular object should be used and what operations you can perform on that object. It's the encapsulation is, like I said, one of the fundamental things about object-oriented programming. I don't want to. I'll answer all the questions that have been posted, but I don't want to stray too far from the original point just yet until I answer the original question from Ken. And so far, does this make sense? Does the fact that we have two methods, one that's responsible for retrieving data and the other one that's responsible for setting data, does that at least does that part itself make sense? Okay,
Did you see in what Curry Joel 1027 said in BuzzNet?
1027? No.
That's his name.
Oh.
He said, hope it's okay. I like that way over the get set syntax.
Properties are yeah. It depends on the use case. It really does. But as far as what properties are, like I said before, languages that don't have properties, you must do this. This is how you do object-oriented programming in languages that don't support properties, Java and C++ and other languages like that support object-oriented features but not properties. A property is essentially a shorthand way of doing what you see right here. So what we can do is declare a property, and we'll make it public because most of our properties will be public. And we can call it name and follow the naming conventions of properties, which are going to be uppercase as the first character. And the syntax inside of a property is very odd looking, I'll admit. But what you do is you open up something that looks like a field. So you give it your access modifiers, your type, and your identifier. And then you open up these curlies. And inside the curlies, you can define two methods. Optionally, you can define only one method if you want. You can define two methods if you want. So the two methods you can define are the getter and the setter. And the getter corresponds to the method you see right here, and the setter corresponds to the method you see right here. So what we can do is say get open curly return name. What I've essentially done is I've used this special syntax, this built-in syntactic sugar, to basically create an entirely new method for me that represents the getter for this property. I can do the same with the setter. I can say name equals value. Well, what's value? Think of value, it is a keyword. Think of value like the parameter that was passed in when setting this property. So now, instead of invoking get name and set name like this, I can simply do person.name equals Nelson. And then instead of saying get name, I can just simply type in name, because that's a property. And the code that's going to execute given an assignment will be the setter. And the code that's going to execute given a non-assignment is going to be the getter. So if I run this code, we will get the equivalent behavior.
And you can see right there, it's exactly the same code, except for the word value, replacing the parameter name in the getter and setter, as it is in your traditional get name and set name methods.
Yeah.
Again, that's essentially a shortcut for doing what you've done there from lines 18 to 26. And then the form where you've got public string name get set is a further shorthand for that.
Yep.
And nothing more. It's a quicker way of typing it out.
Yeah, and it just looks nicer, depending on the situation. This was covered at the end of 101, but these concepts are so important that I don't want people being left behind on properties. And we'll be over with properties here very shortly. I just wanted to give a quick review.
While you're talking about properties as well, did you ever cover protected?
No.
Okay.
But you must set it first. Not necessarily. If I don't set it first, person.name is going to be null. And as you see, nothing gets printed out. So there's no reason why I don't have to set it first, just like I don't have to invoke the setName method first. There's no order that's constrained for us. So never use public unless it's for a function or a method. Unless it's for a property, a method, or an event. Those are the three things that are typically going to be public. Anything else is going to be private or protected. And you really want to follow that convention, because following that convention will lead you into... Following that convention will implicitly lead you to writing properly encapsulated code.
I tend to start off with the most keeping everything as private as I possibly can.
Right.
And then when you try to access something that's private from somewhere else, you'll get an error saying cannot access due to inconsistent accessibility or whatever the other error is for that. And at that point, you can then go, actually, do I want to make this public, or should I be doing this a different way?
Right. And then if you do want to make it public, you have two choices: make a method or a property. The difference between something like getName and a property that gets the name, the biggest difference conceptually is that properties are typically going to be considered more lightweight than methods. So if you have a lot of computation, like maybe you want to talk to a web service or something, I would highly advise against using a property in that case. Now, if you need to do some basic computation like appending first name to last name or some other computation side of a getter, that's completely fine. But methods should generally be reserved for things that are more heavyweight than properties. Properties just feel lighter and will be considered lighter by other developers.
Just finally close that off, you could just show an int-based example with the setter checking.
Well, yeah, if we wanted to have like an integer dividend, that's the right one, right? That I'm thinking of?
Yeah.
So here we're enforcing a particular constraint. Okay, so moving on. Private helps keep the memory levels down. No, private does not in any way. Accessibility modifiers do not affect the way that an object is laid out in memory and will not allocate any more or any less memory. All right, so moving on. Cannot set dividend to 0 because you're doing it anyway. Well, in this case, what I would do is I would have a constructor that set my dividend to some sort of valid number.
I was just imagining doing an int.trypass in it to make sure that it was actually an int or something. You know, basic error checking.
Yeah.
Is the sort of code. You don't want to be putting many more lines of code than that in a property, generally.
Yeah. Can you go over inheritance constructor? Sure. Basically, when working with inheritance, and again, this is just going to be a cursory overview because we do have a lot to cover today. If we have a constructor on our person that isn't the default constructor, remember the behavior of how classes work in C#. If there's no constructor, an empty one is generated for you. If there's another constructor, that empty one is not generated for you. Meaning that by putting this constructor here, we are saying that the person class can only be instantiated when given a name. And we can go ahead and say private string name and then actually do something interesting with this data. So by saying that you can only instantiate a person given a valid name, it doesn't make sense that this should work. And the reason why this shouldn't work is because constructors are not inherited. Constructors are not passed down to their children. So as a result, if I try to compile this program, you'll notice I get an error. And the error is that employee must in some way invoke this constructor when the employee itself is constructed. So what we can do here is we can say public employee string name, provide a constructor, and then add a colon after the last parenthesis but before the curly brace, and type in the base keyword followed by an open paren, and then pass in the proper values for the constructor. So at this point we are properly invoking the base constructor when we instantiate an employee. So as a result, if I say emp equals new employee and emp.display, you'll notice that the data properly got threaded through the employee constructor all the way down to the person constructor. Is there a reason to use a property instead of public when we're including both a get and set property? Yes. If you have a property like, even if you have an automatic property that looks like this, This is still much more preferable to using a field. And there's a lot of there's a lot of reasons why this is. First of all, you can't override fields. So if this were virtual, we have the opportunity to make this virtual. Previously, we wouldn't. Fields cannot be virtual. Now, the second thing is going to obviously be that we have the option to provide functionality here whenever we want without breaking existing code. Another reason is it's a convention. It's just how things are done. And it's not a superficial convention. It's also in regards to things like reflection and metaprogramming, where we're not going to be talking about reflection and metaprogramming in this course, but it is a topic that does rely, when a person creates a program that in some way goes over your program at runtime and looks at your classes, the general convention is that properties need to be not necessarily be public, but properties are the standard, conventional, proper way to expose private data, period. And that's how things are. There are good reasons, there are good cases for properties, but overall, the overarching theme is that's just how things are done.
They're the FedEx envelope around your parcel. They only come in certain sizes.
Yeah, and you get some implicit flexibility by using properties as well, and it's just something that you really want to do. Let me see, Brandon. Plus, that has child classes so that we could keep a list of pets with ease, or are there other benefits designing them that way over having each child class be its own class and not inheriting the properties from the abstract class? So that goes back to the homework where, let's say I have an abstract class person.
Well,
and then
are you going to go? Actually, you actually going to go over the homework tonight?
No, I'm just going to really quickly throw out an example.
You could go over it tonight. It's been handed in.
Now, the biggest reason why it is important that these all inherit from a common base is so that we can write more generic code. We can write code like this. This code right here is the reason why it's good, flexible, reusable, and important, and less, as in there's fewer lines here than I would have otherwise to do the same thing, is that we are simply requesting that the user passes in a list of classes or a list of objects that are instantiated from classes that inherit from person. And because of that commonality, this method can be used for a variety of different purposes. We can print a list of employees, of janitors. We can print a list of employees and janitors. And we don't have to retype the code out. This level of polymorphism is absolutely paramount to how to write cleaner code. And we are going to be looking at that sort of thing later on. Once we start talking about interfaces and state machines and commands, we're going to be taking a really in-depth look into why it's so important to create common base types, not necessarily classes, but base types that we can use in a generic fashion with our code, because it really allows us to express things in a much cleaner, higher level way. Because remember, if your pets didn't all inherit from the same base type, you wouldn't have been able to store them in a list of pets. You wouldn't have been able to make methods that just accepted a pet. You wouldn't be able to create a while loop that performed functionality for possibly up to millions of different types. Because otherwise, if they didn't all inherit from pet, then you would have to write code specific to each class that you put together. Okay. I made a pet list, and then when I set pet's index, I got the namespace with the object, so homework 1 dog. How would I make the output dog and not the namespace with it? Oh, well, so the question was... Actually, I'm using implicit typing. You can't stop me.
I don't want to stop you.
Okay, so the question was, how could I print out the type of each one of these objects? So I want the output to be employee and then janitor. Now here's how. Now, this implementation might not seem particularly elegant to people right off the bat, and it is a little bit messy, or not. It's not messier. It's actually, for a variety of reasons, it's a lot cleaner. But it does seem like a lot more code than what we could do as easily with reflection or printing out the type of an object at runtime. But you should never do that, and here's why: the end user will always care about text being formatted in a way that's appropriate to them, to their culture, to their settings, to their preferences. You want your code to be capable of formatting text that is printed to the end user in a way that it sees fit given a particular context. Relying on reflection to print out something to the user by saying person.getType.name, we are inadvertently exposing an implementation detail to the end user. An implementation detail that if we were ever to change for whatever reason would ultimately change the output of our program. We want the flexibility to have these types named whatever we want. If we want to present the data to the user indicating what type they are, we instead will use something like this. Now, this isn't the only way to do it. We could store a dictionary of strings and types and all that stuff, but obviously we haven't even really talked about dictionaries yet even, so we can't do that at this point. But what I'm trying to say is the text that is presented to the end user should be up to the code itself, not to some sort of built-in framework or library or reflection or anything else. You really want to have the flexibility to change these sorts of strings that are presented to the user. So
if you wanted to roll this out in for the French division of your company, for instance, obviously your employee would now want to return that in French. Similarly, the janitor would want to return janitor, but in French, whatever the,
Right. So generally what you would do is you would have like an internationalization library, and you would say, internationalization.translate, and then you would typically either pass in a string or an enum, like strings.janitor. That's the kind of stuff that you would do, you would write if working in a multicultural environment. You could not do this if you were working purely with reflection or taking advantage of your implementation details. Okay,
Sequel just pointed out you spell mutant wrong, but you spell internationalization correctly.
Really? I thought I got that wrong. Huh.
No, but you spelt mutant the other day as if it was a very small tent.
Well, whatever. Let's see. Are there any rules of thumb that might be using when designing a set of classes? Perhaps helping to determine which classes should be abstract or implement interfaces and what access level should be given to different classes. That question is basically what this entire 102 course is about. We're going to be introducing object-oriented features, and we will be discussing the design of those object-oriented features in order to reach a particular goal. So I can't answer that directly because attend the classes.
You'll spend the rest of your programming life coming up with them and finding them and breaking them. Is the answer to that one, I think.
Yeah, it's an ongoing process. It's really a skill that you will develop, and this class is all about teaching that skill the best way that we know how. When you call a method from a base class to invoke a function, say to add all fingernails, and give it a number of hands, how do you call that method when the class cannot be instantiated directly? Would this be used for a template method? When you call a method from the base class to invoke a function and give it the number of hands, how do you call that method when the class cannot be instantiated directly? Well, what you could do, you can. Well, words. Okay, so if you have like an abstract class person, and let's say we have a public void add length to all fingernails. If we did have a private int, or let's just leave it public int for now. It would have been protected, but in words, public int get number of hands return 2. We could say, var number of nails equals get number of hands times 5 for var I equals 0, I smaller than number of nails, I plus console right line adding length to fingernail blah. Now there's nothing wrong with writing this code. We could say person dot add length to all fingernails. And this would work because we're not instantiating the person class directly, but we're instantiating its children, its employee and its janitor. And by running this code, you'll see we get the expected output. Now, this isn't typically something you would want to do because you would want to give the flexibility for determining how many hands a person might have, most likely to its subclasses, because everybody knows that employees and janitors have different amounts of hands. So what you would do instead is you would make this method a template method by making an abstract, and then you would implement it in each one of these different classes. So for example, an employee has 5 hands, whereas a janitor might only have 1. So what we've essentially done is created a template, or followed through the template method pattern, to where we are asking the children classes some bit of functionality. We're invoking functionality on the child classes directly inside of the base class. So now when you run this, you see that things work the way we would expect it to. The employee gets length added to 24 fingernails, or 25 fingernails, sorry, and the janitor gets length added to only 5 fingernails. So this is an example of a template method where we provide some functionality in our base type that depends on functionality of our child types, but we're using abstract and override in order to provide that functionality. Did that answer your question, Xander? I did get a question. If let's say I have an automatic property here, public string name get set, does this break encapsulation? It kind of does. In this, it really well, like you said, does it depend on the situation? It does depend on the situation as well. But generally speaking, I avoid public setters on properties because it does break a level of encapsulation, because in a lot of circumstances, the properties that you have, the state, the data inside of inside of your class is not the same as the data that it can provide you or the way in which you interact to set data. So generally, what I will generally do is I will make, on certain types of classes, now this is important to note that it does depend on the situation. There are objects that are called DTOs, or data transfer objects, that might get away with having public setters and public getters, and that will be perfectly acceptable. But for more intelligent objects, I will typically set the setters to private and instead provide a method that speaks in some sort of language called, like for example, set name, that performs the computation to actually set the name. I find that the language is a lot nicer, and I find that it provides me the ability to it just does feel nicer to me. In some circumstances, you only want to set a particular property as a unit. So, for example, you might have, let's say we have a public string address. We have a public int zip code, and we have a public string state. All of these things are an address. Now, this is a prime candidate for something called a value object, but we're not going to go into that right now. Instead, I want to, excuse me, need some water. Instead, I'm going to show an example of when it makes sense to set multiple pieces of data as a unit. So I would have a method. I wouldn't have a method named set address or set zip code or set state. That doesn't provide much value. Instead, I would have a method called move. And doing it this way has a lot of benefits. One of the benefits is that I can validate the entire address as a whole. Like, for example, what if I wanted to make sure that the zip code they tried to set it to was valid given a particular state? That means if I put that validation here on the setter of zip code, the order in which the person actually executed the move command would be different. Because, for example, if I had functionality in the zip code that threw an exception if they tried to set the zip code to a zip that wasn't in the state they were in, the callers of the person, the consumers of the person type, would have to implicitly know to set the state first before the zip code. Otherwise, it would trip up the validation. Well, what if I did the other way around? What if I only wanted to set the state to something that, or I wanted to enforce that the state was only set to something that was in the zip code? Then it would be the other way around. You'd have to set the zip code before you set the state. Well, what if I did them both at the same time? The zip code makes sure that it's a zip code in the proper state, and the state makes sure that it's a state that contains the zip code that's already set. Then we have a catch-22, and we can't set either of them. So in this case, I would give a method like move, which not only provides a really nice language for our object, but also gives us the ability to validate a unit of values together as a unit.
Again, a lot of it comes down to...
I don't know what the initial question was, but did I help somebody?
Basically, again, it comes down to putting as many strictures, I was going to say as possible, but as makes sense on the end user of your code. Always write code as if somebody else is going to be using it.
Right.
And it's amazing how many more errors you'll spot. Even when just checking a console application, pretend that you don't know that you're supposed to enter a number between 1 and 7. And then read the prompt that you've given, and does it tell you that those are your options? Or does, those sorts of things, which it's very easy to go past, and this will come up, I'm sure, a lot with the logic of the game, this class, is in terms of puzzle solving. It's very easy to write puzzles that are impossible because you know the answer because you're writing the puzzle. And it's the same thing here. You know what you're supposed to do with the code because you're writing the code.
Yeah.
Your user is always an idiot, beg fault.
Yep. But, it's not just for other people, it's also for you in 2 hours.
but that qualifies as someone else to me, because I can't remember. Who are you?
Yeah, pretty much. And so by establishing, object orientation is all about establishing a language in your code. You're creating your own little environment, your own little engine, your own little city where you have entities within your city that can communicate with each other on a certain level. And you really want to give a lot of good value to the names that you use and the ways that you express your code so that it looks good. And not in a hipster sort of way. I saw something. I just have to say this because it was horrible. It's there's this project called Bootstrap. It's some JavaScript project or something. But somebody made a bug report on it saying that JSLint, a JavaScript validator program, was throwing an error trying to validate Bootstrap because the author had used an obscure language hack in order to avoid adding a semicolon to a line. And then the author of Bootstrap actually replied and said, well, maybe JSLint should change the way they validate their code. And then the author of JSLint was like, no, I'm not going to do that. And then at some point, one of the chairmen of the specification of JavaScript got involved, and it just digressed into like this like 200 comment thread on GitHub about this missing few comments. And they called them hipster programmers. That's what they called them. But
really, the geek shall inherit the earth.
Yeah. So right. When I say make things look good, I'm not talking about using an obscure language hack to avoid adding a semicolon. I'm talking about providing good naming, providing value inside the names that you choose. Okay. So could you briefly run through naming conventions in C#? I noticed you used names like name, and name.
You covered that previously.
Yeah, we have. I'll just briefly run through it, though. Classes.
Because we.
Classes, properties, methods should all be Pascal case. Fields, it's up to you. You can we will accept either underscore followed by camel case, or we will accept camel case. Public fields, not that you should ever have them, should be uppercase. And that's really about it. Local variables and parameters should be camel case as well.
With no leading underscore.
Yep. Okay, I mean, because the dividend equals value is not in the if bracket clause, so it gets run no matter what value. In my previous example when I had a public int dividend, I doubt that's how you spell it.
It is.
Wow, I'm just on fire today. No. This will not get executed if the exception is thrown. Remember that the exception unwinds the stack until it finds an appropriate catch clause. So when this exception gets thrown, execution in this method gets terminated. So line 21 never executes. Meaning that this and this are perfectly equivalent code. It's just this is better. Are for each loops generally better than for loops with a count? I've been using for loops to do the same thing a lot. For each loops are always 100% ridiculously preferred over for loops, with the exception of if you need to have a counter variable. Even then, I do sometimes find myself doing this, depending on the situation, because it is... What?
I was just going to say, for details on this, really, you covered this in quite a lot of detail in the one we did just now.
Oh, right.
The Open Office.
It felt
it's just because people have been saying, and time's moving along, and we haven't started on this week's stuff yet.
Yeah, sometimes I do this. Otherwise, do a for loop. It's up to you. But if you don't need an index variable, always use a for each loop.
That said, while you were just talking about naming conventions, constants.
Could you have constants in the class as well? Oh, yes. Constants can be as public as you want them to be. Typically, I always actually I generally do Pascal case on constants. I don't write a lot of constants. It's generally I'll use.
I'm quite happy to look at Pascal case or at block caps with underscores if for those whichever way your Visual Studio is telling you to do it.
Yeah,
is okay by me.
But they're not going to break encapsulation or cause any object-oriented problems. Although there are some considerations when talking about public constant fields versus or public static read-only fields versus public static properties. But let's move on.
Quite.
So wait, are you saying that person index.name would be bad or good? Because that's what I did for the homework. It's not preferable. If you do not need a counter variable, you should generally use a for each loop, because for each loops are cleaner, and they also support a lot more functionality than for loops do. We're going to be getting into the magic behind for each loops in the last week of this course. William, we haven't even gone over interfaces yet. We actually we had to cut the last class not short because it ended up being really long, but we had to.
That's what today's class is basically going to be about.
Yeah.
In large part.
All right.
And I think brings us up to the break, I guess, because we've been going about an hour, and then you can start fresh into inheritance afterwards.
Sure. We're about 46 minutes of recording time, so I can go ahead and pause. Okay, we are back, and we are going to be talking about interfaces.
Yay!
Yay. Okay, so everybody at this point should have a good feeling for what an abstract class is and how to use it. But abstract classes have a lot of problems with them. Now, it might seem at first that they're great because, I can have an abstract class, well, I know this is a tired example by now, but still, with abstract members and all that cool stuff.
Do it with cars.
Sure. Talking cars. And then we can have maybe some implementation here called,
Knight Rider.
drive, and it might say room.
Turbo boost.
And then maybe some things.
Turbo boost method.
And maybe something like public virtual void turbo boost. I don't get the reference. I don't know Knight Rider.
That's because it's older than you are.
So we get some really cool stuff here with abstract classes. And at first it seems like abstract classes are really the solution to a lot of our problems. They allow us to do polymorphism. They allow us to provide default implementations for things. We can have virtual methods, non-virtual methods, abstract methods. And it seems like it's really great, but they're not. One of the problems with abstract classes, the number one biggest problem with an abstract class is you may only have one. You may only inherit from a single class, which is problematic. Now, it's not problematic in this sense because we've really defined a car, and we have this huge, monstrous class called a car, and it does. In our object model, we have this object called a car, and it does everything that a car can do. But you know what? That's not how big software gets written. That's not how clean software gets written. Because we've created this huge monstrosity of a class that becomes very difficult to change. Because if we were to change the implementations on any of these look great. These default implementations look awesome. They're really appealing. But remember, if we change the default implementation here, we change it among every child car class. Every class that inherits from car, we've changed the implementation, and there's no way around that. So that's the second big problem. First of all, you can't inherit from more than one type. And second of all, if you change the default implementation for a particular method, you have just potentially broken a lot of code. Not very good. So now, again, and I was alluding to the third problem, and that is abstract classes promote monstrosities. They promote classes that know everything about what that class does. They promote classes that are not very flexible and cannot be used in situations very easily. Like, for example, let's say we have an abstract class movable. So we're getting a little abstract here, and no pun intended, but we're starting to talk about breaking our components up by what they do. We're performing a refactoring that allows us to represent bits and pieces of our classes, but not themselves in their entirety, which will allow us to mix and match different functionality with each other. So we have our abstract class movable, and then a car is, of course, a movable class. But then we might have an abstract class purchasable. And now we run into a problem. The problem is that a car is both movable and purchasable, at least the car that we want to represent here. But everything that's movable isn't necessarily purchasable. Now, why would we want this functionality? Well, let's say we have a big bag of objects, just a list of objects. And remember, object is the base class for all types in .NET, so we can store anything in this list. And let's go ahead and have a class car1 that's a car or something. It doesn't really matter. And then, public override whatever. So we have a big bag of objects, and let's stuff some objects in here. We might have a 10 object, and we might have a whoa object, and we might have a new car object, a new car one, and we want to provide some functionality to our user. So this is the bag of objects that he has, or that's maybe available to us in an inventory. But we want to, for example, list all the purchasable things. So we want to purchase everything, or present the list of to the user. We want to present them a list of everything that's purchasable inside of these objects. So we can say for each var item in objects, and we can say if item is purchasable, or how about I invert this? If item is not purchasable, then simply continue. We don't care about him. Then we want to cast it to purchasable. So we'll say purchasable equals purchasable item. And now we can say something like console writeline, do you want to purchase this? And I'm just going to pass it. It doesn't really matter.
Purchase.
Well, whatever. The spelling's irrelevant here. The point is that we want to have a list of objects, but we want to know if those objects have a particular characteristic. Now, the is operator we did cover in the open office hours, and I did say that we would cover it a little bit more in depth here. And actually, now is actually a good time to talk about is and as. So people in the open office hours already got that, but for people who didn't attend the open office hours, not expecting there to be any new content, to be fair to everybody, we're going to go ahead and cover is and as here. So is an operator that says, is this object of type purchasable? Not specifically is it of type, it is, does this object in some way derive from purchasable? And if it's true, then it returns. If item is of an object that derives from purchasable, this will return true. And then, of course, we negate it and then continue if it's not. The as operator, which would be a little nicer to use here, looks like this. We can say if purchasable doesn't equals null, then continue. Now the as operator works like the is operator, but it's a little bit nicer. What it does is it says, is this item a purchasable? If it is, return a variable of type purchasable. If it is not, return null. So we're detecting if this item is purchasable. So if we go ahead and make our movable, let's just say, okay, well, we've dug ourselves into a hole, let's dig ourselves further. We're going to say all movables are purchasables. So, sweet. All movables are purchasable, which means that the car that we add to this list of objects is now a purchasable item. So when I run this program, you notice that we get, do you want to purchase a car? So that's what we want. It ignores the 10, the integer in the string, because neither of these are purchasable. But because the car is, we get this functionality here. Are there any more questions about is and as? I mean, they're very straightforward operators. Basically, again, just to quickly recap, the is operator returns true or false if the object on the left is a derivative of the type on the right. The as operator does that, but a little bit more. It doesn't just return a Boolean. It says, okay, if this item is a purchasable, return a variable of that type. Otherwise, return null. Do is and as ever throw an exception? Is and as do not throw an exception, which is the #1 difference between casting and using the as operator.
Is will always either return true or false, and as will either return the item or null.
How would you have it write console application 1 dot not write console application 1.car1? The output here is irrelevant. It was just something I tossed in there, just for demonstration purposes. Generally, I would have like maybe a property on purchasable called name, for example. I wouldn't do this in the real world, basically. But I just want to make sure everybody's good with is and as, because then we're going to be moving on.
Looks like it.
Okay, so sweet. So we have a problem here, and the problem is that our object model is really nasty, because we really want our car to be movable and purchasable. Because what if we wanted to write a loop that moved things that are movable? Maybe the loop presented a list of things that are movable and asked you which one you want to move. Maybe
well, you'd want to be able to move the car once you'd bought it, because otherwise you're just going to be leaving it at the showroom.
Yeah,
and it's not going to be much use.
So that puts us in a situation with single inheritance, because we either have movable not inherit from purchasable, which means anything that's movable isn't purchasable, or we do, which means that, like, for example, a person is movable, but they're not necessarily purchasable.
Well, I'll tell you what, add in a couple more classes. Add in a chair class that is movable but not purchasable, and a manual class that's purchasable but not movable.
Yeah, this is impossible, basically. If I add a chair class, he's movable, but this becomes a problem. And he's purchasable. Why did I make him static instead of abstract? Why am I even making him abstract? Doesn't even matter. We have a chair that's movable and a manual that's purchasable, but because of the way single inheritance works, our chair is both movable and purchasable. You wouldn't want to have all of your chairs in your living room have a price tag on them. You know, that would be stupid. You don't want people walking in and just buying stuff out of your house and walking out with them. So you really want to be able to distinguish between if something is movable or purchasable. And that brings up interfaces. So I'm going to go ahead and nuke this code. And let's talk about what an interface is. An interface, at a level that everybody here will understand right now, just because we've just gone over abstract again, an interface is a frozen IDE.
Oh, the irony.
There we go. An interface is basically an abstract class that may not have implementation in it. An interface cannot have implementation in it. Everybody repeat with me. An interface cannot have implementation in it. An interface has no executable code. For example, an abstract class can have executable code. Abstract class, we can have a public void hey method. In fact, an abstract class, we don't even have to make anything inside the class abstract. We can just have an abstract class. And we can put as much implementation here as we want. But an interface cannot. An interface, think about an interface as every single member in an interface is abstract and has no implementation. You cannot instantiate an interface, just like with abstract classes, but you cannot have implementation detail, unlike abstract classes.
It's like the contents of a book, almost. It specifies what's in there, but doesn't tell you anything about it.
Yeah, or a contract. It's just a way to describe the existence of something, but that something is not defined. So what can we put in here? Well, we can put in methods, properties, and events. We may not, and I know we haven't talked about events yet. We're not going to be talking about them probably until 103, but I just like to be complete when I say things like that. We cannot have fields in here. In addition, everything in an interface is public. There's no way to use the private access modifier or the protected access modifier within an interface. So let's talk about what a movable interface might have. It might have a void and move method in it. And then let's have an interface called IBuyable. It might have a few things. It might have a decimal price with a getter, and it might have a method called buy. So the syntax here might look a little funky because it's deceptively similar to a class, but it's really different. What's going on here is we are defining these methods and these properties. They do not have access modifiers on them because everything in the interface is by default public, and they can't be private or protected. And they don't have implementations, just like abstract members. But they don't need to specify the abstract modifier because, well, everything in an interface is going to be abstract in the first place. So these are really just like templates. In a sense, yes. They are like templates, but they allow us to do a lot of neat things with them. So why prefer interfaces over abstract classes? Well, the absolute number one reason is that you can implement as many interfaces as you want in a class. Class can implement as many interfaces. It can implement as much functionality or as many contracts as it needs to in order to work. So let's go ahead and talk about how we can implement an interface. A car is movable and it's buyable. If you didn't catch what I did was basically, I'll just back up. So we have a class called car, and it's movable and buyable. That's great. And the car class, because it implements these interfaces, and notice how I'm using a very similar notation as inheritance. It's in fact just the same. You can inherit from and implement interfaces and classes. So you can inherit from a class and implement additional interfaces if you wish. In that case, you always put the class first. But other than that, interfaces are just listed at the end after the semi.
Is that, when you say you always put the, is that just convention? You put the class first, or does it require it?
You know, I've never actually tried it before. Yep, it's built into the language. There's no way to add this at the end. It's just, I wouldn't ever do that. Like, that would look ugly.
No. It's probably much the same way you can't add optional parameters before other compulsory ones.
Yeah. So in a sense, it's like inheriting from more than one class. Kind of, sort of, but it's not inheritance. It's not inheritance. However, that being said, because we just have talked about inheritance in abstract classes, you can for now think of it like inheritance, for now. And that's just because it's a very similar thing, but it's different. It's implementation. Now, if I try to build this program right now, I'm going to get an error. And the error that I'm going to get is going to be similar to the error that I would get if I was inheriting from an abstract class with an abstract member that I didn't implement. So what I'm going to go ahead and do is provide implementations. First, I'm going to provide an implementation for my price. Then I'm going to provide an implementation for my buy method. Then I'm going to add an implementation for my move method. I'm going to just throw in a nice little constructor here. Now you notice that the build is indeed successful. The reason is I provided implementations here. Notice some key differences. First of all, I do not have to annotate these methods, specifying that they are implementing an interface. This is called implicit interface implementation. Now we're not going to be talking about the alternative in this class here, but this is generally how you will implement interface members. Next thing you'll notice that they're all public. That's another aspect of implicit interface implementation. They must be all public members. But because these signatures align with the signatures from the interfaces, they are actually providing an implementation there.
Could you just talk momentarily about the missing setter and when and where that happens? Because I find myself tied in knots by that sometimes. I go round and round in circles following Resharper's advice and getting back to the same place I started with.
You mean the fact that price doesn't have a setter in the interface?
Yeah, and then sometimes when you have a get private set, I think probably in that example I paste binned you where you're composing an abstract that you then inherit from. I had problems setting a private setter in there.
Yeah, basically if I put a get set in the interface declaration, what's going to happen is this is no longer going to implement it properly. And the reason it isn't is because this is a private setter, and everything in an interface is public. So the way to allow for classes to have a private setter would be to simply not specify that that property needs a setter inside of the interface itself. What happens if you have two method names and the same method names in two different interfaces? That's where explicit interface implementation comes in. So if I have a void move method here, you'll notice that the code still compiles because this method matches both this this definition and this definition. Now there is a way with explicit interface implementation to decide which one of these you want to fulfill, but we're not going to be talking about that just yet.
Well, you simply would give it IEnumerable dot.
Yeah, and you would take out the public, but that has different ramifications because explicit implementation is all private and all that stuff.
Cool.
Can you substitute interfaces for any instance where you would use an abstract class? No. You cannot substitute interfaces for instances where you have an abstract class that has functionality inside of it, because you cannot represent functionality inside of an interface. You also cannot represent fields inside of an interface, because fields are an implementation detail.
I was talking about this with Sequel yesterday, and would you basically say that given the choice between the two, you would prefer an interface than an abstract, except for when you're forced to use an abstract in order to have some implementation?
Generally,
as a rule of thumb.
Generally speaking, every object that I use will generally be hidden behind an interface, and I'll expect the objects that I create to be communicated with each other via interfaces, typically, especially across system bounds. But sometimes there are cases where there's a bunch of default functionality that I don't want to repeat everywhere, and I'm willing to sacrifice the integrity of the design slightly in order to provide some functionality for myself. In that case, I would do both. I would have an interface Then I would have an abstract class that implements that interface and tacks on a bunch of additional functionality. By doing that,
I wondered about that.
Yeah, by doing that, I don't tie myself to a specific abstract class, so I can still, if I really wanted to, not have to tie myself and bog myself down with that abstract class. But for convenience, I might still use that abstract class.
Cool. That's what I was trying to get across in that pastebin example. Couldn't quite get it there.
Can you have an interface defined that inherits other interfaces or uses a container of sorts? Interfaces can inherit from other interfaces. So, for example, I might have a interface IExpression or IStatement, and then I might have another interface called IExpression, and this might have an object evaluate method, and then this one might have a actually we'll have like a void execute method here, and then we'll have like an object get value here or something like that, and then I could make them inherit from each other by doing this. Now the behavior of doing this, interface inheritance is not the same as class inheritance, meaning if I have a class that implements IExpression, what basically happens is he simply inherits IExpression and IStatement. He doesn't just inherit IExpression and IExpression inherits IStatement. He inherits or implements both of those interfaces. So it works a little bit different. The answer is it's possible, but there are some quirks, which I don't want to get into too much right now. Can an interface implement another interface? Yes. Well, it's actually not called it. When a class implements an interface, that's called implementing an interface. When a class inherits from a class, that's called inheritance. When an interface inherits from an interface, that's called interface inheritance. And they're all different concepts, just to make it not confusing.
And they all begin with I.
Yeah. Does an interface have to start with an I, or is this naming convention? This is the naming convention that you will see represented everywhere for everything in all .NET code that's ever in existence.
And if or when you start using Resharper, it will recognize and make use of that fact in moving around and constructing code. If you start a class with an I and then something else, it will assume that it's an interface.
Yeah, it's not built into the language, but this is one of the conventions that I have seen broken maybe 5 times in the time I've spent working in C# by other developers. So it's really, really, really ingrained into how you write C#. If IMovable.move and IBuyable.move took different arguments, would the compiler differentiate, just like overloading? Yes. If IMovable.move had an int x and IBuyable.move had a float y, these are 2 separate methods, meaning that the car class would have to implement this overload and this overload. When you first wrote the class car IMovable method, it looked like you did some voodoo to automatically populate. Yeah. I did that kind of like instinctively. Basically, I placed my mouse cursor over IMovable. By the way, this is built into Visual Studio. In Resharper, I will use Alt-Enter, which is a lot nicer, but Visual Studio also has built-in functionality. If you hit Control Dot and then Enter, you'll get the implementations put in for you. So that's Control Dot Enter. But again, if you have Resharper installed, just use Alt-Enter.
And people are asking for a pop quiz. Someone wants examples.
Well, I'm thinking of one right now.
An example to code up. Well, what about a computer? Different size PSUs, MOBOs, specs, laptop, PC,
you could
tablet, on. Any combination of the above to make examples of each bit of this?
Yeah, I do want people to do something, but let me...
An Intel Mac implements IIntel and iMac, which you couldn't do with Abstract.
Yeah,
Anyway, sorry.
The thing though, in that case, I would use composition because a computer contains multiple components. You know, computer isn't a CPU.
Yeah, like that, with like your Immovable, iBuyable. That's exactly what I was thinking, as it goes.
Hold on, we did get two more questions. I think I'm now confused on the meaning of implementation, as I thought it was simply meaning it takes on previous methods from an inherited class. Which week's class was that taught so I can review the video? I think previous methods from...
It's basically confused because it's implementation and inheritance. What you thought was implementation is inheriting. You inherit from an abstract class, but you implement interfaces, and it's just indicative of the fact that you're not doing quite the same thing. And it's particularly confusing because they both use the colon for the symbology of it.
Yeah, I mean it's the same list essentially.
Essentially, if you're talking about interfaces, then you'll get used to the phrase implementing this interface. The two words go together. Sorry, carry on.
Okay, so a question came in about operator overloading. The answer is no. Operator overloading, the way it works is very funky, and we'll need an entire class, or not an entire class, but we'll need a good portion of a class to talk about it. The answer is no, but yeah, it's due to the nature of how operator overloading works in C#, it's not possible to use them on interfaces. And operator overloading itself introduces a lot of oddities. Okay. So, well, I say one thing we could do is this. I'm going to have an interface item.
Do you want to clean out the preceding code and start with a nice clean?
No, I'm going to have people complete this example.
How are you going to be using it?
Just because somebody asked so nicely for a pop quiz. Okay, so here's what we're going to be doing. I'm going to go ahead and everybody who wants to participate, go ahead and hit the participation button.
Do you want to just line wrap line 37?
All right. Well, I'm going to go ahead and reset everybody's ready button. And what we're going to go ahead and do now is go ahead, copy this code down, and then create a list of items inside of main. Then create, well, here, I'm just going to do this. Copy code down, create at least one additional class that implements item and only one of the other two interfaces. In main, create a list of items, populate the list statically, and allow the user, or enter infinite loop, allow display each item, and if it is movable or buyable, and allow the user to move or buy an item. Okay, so I'm going to go ahead and pause the video. Okay, resuming the video, we did have a question. So, with inheriting abstract methods that have functionality, you can't inherit multiple. You can implement multiple interfaces, but those can't have functionality. So is there any way, possibly something we'll learn in the future, to inherit or implement from multiple things that do not have functionality in them? Basically looking for the equivalent of a method inheriting functionality from multiple parent methods. Generally, that problem is solved via composition, where you will break your individual class into multiple other classes that perform the actual work. And then what you could do is you can reuse those smaller classes in part with other classes that you might create.
Could you just error check my paste bin to make sure I'm not saying anything wrong in it, and if it's correct, I'll just pop the link in Buzz now.
So moving on, we are now unpaused.
Cool.
And let's go ahead and take a look at this code. So the first thing is create at least one additional class that implements item and only one of the other two interfaces. So I'm going to create a chair, and I'm going to make it implement item, and I'm going to make it implement Immovable.
Talk about what you're doing.
I'm just creating a implementation, giving it a constructor with a single parameter, and I'm going to go ahead and implement the move method. So we have a class that has a property called name. It implements item, Immovable. It has a constructor that takes in a single string parameter, and it has a method named move that simply prints something out to the console. So now, what else do we have to do? Let's go ahead and create a list of items. So var items equals new list of item. I'm going to fill it with some stuff. I'm going to say items.add. Let's create a new car and give it the name of stuff and a price of 32.45. Let's add another car. Call it and. Let's create another car. Call it things. Let's create a chair.
All that car making's tired you out. You need to sit down.
Yeah. We'll call this one comfy, and then we'll add another chair called awesome. And I'm going to go ahead and just move this up here and just swap things around a little bit. Then I'm going to get some errors because I need to add the M suffix. Okay, so now I have my list of objects. So let's go ahead and enter a while infinite loop.
You can start deleting some comments. Yay.
Okay, enter an infinite loop. I want to display each item and if it's movable or buyable. So I'm going to go ahead and say for each, well, I'm actually going to go ahead and say int index equals 0 or var index and say for each var item in items. I'm going to say console write line bracket index item dot name index plus plus, and actually I'm going to turn this into write. I'm not going to have a write line because I don't want a new line. And then I'm going to say var buyable equals item as I buyable, and then I'm going to say
you're going to spare.
Yeah, if buyable does not equal null, say console.write costs bleh, so buyable.price. And again, this part, the costs is irrelevant here. You didn't fail if you didn't put this in here. I'm just throwing it in there just for a bonus. Then I'll say var movable equals item as I movable, and say if movable does not equal null, console write can move. Then I'll simply do console.write line to get a new line character. Then I'm going to say console write choose item, and say var item equals int parse console read line, or sorry, item index. I'm going to say if item index is smaller than 0 or item index is greater or equal to items.length, or sorry, count, then continue the loop, because obviously the user was dumb.
Console right then, you are dumb.
And then we'll go ahead and say var chosen item equals items at item index. And then we'll say var movable equals chosen item as I movable, var buyable equals chosen item as I buyable, if movable. Oh, come on. I hate that stuff. Me throws up hands in defeat.
Is movable.
Or not is movable, but the movable component. See, normally I typically wouldn't have all of this in a single method. In fact, you know what I'm going to do? I'm going to take this out and I'm going to turn it into another method. I'm going to say static int choose product list of item. Don't worry, Nada, we'll go over everything line by line.
And this is how coding goes. You know, oh, I don't want that to be in there. I'm going to chunk this into another method. That is very much, certainly, probably more so at my level than Nelson's. I write spaghetti code and then pull it apart and rebuild it in a nicer, shinier looking way. You need to be quicker on the print screen button, Nata. And yeah, that's what it says. And you should do that rather than having massive 1,000-line methods.
Okay, so now we can select an item, and then we can go ahead and ask the user if he wants to move it or to buy it. So we could say if movable is not equal to null, then console write line 0, or how about just 1, or how about just m, or how about just console write.
How about just. What do you want from me? I know, Nada. He'll go through it once he's built it all.
Or, sorry, what am I doing? Definitely getting up there in complexity as far as the code that we are writing, but interfaces are a way to deal with complexity.
I know I keep banging on about this, but it's all about breaking the problem down into smaller little sub-problems and then doing the same thing to those until you're at a point where your description of the problem essentially looks like C# code almost, because it gets down to the point where you're saying, well, if this is true and the user does this, do this, otherwise do something else. And you're literally, you know, you could write that out using if and else if and so forth, and it'd still be perfectly understandable English.
Yeah. But yeah, so let's go ahead and run this program. We get, actually I don't like the 0 into C. Index. Okay, so let's do an awesome and let's move it. And now we have moving the awesome chair. So first of all, I am going to go ahead and add some delineation so the console output doesn't look.
Go ahead and change the user so that they can't input 0.
Okay, so now let's say we want to stuff and we want to buy it. And I just bought a car for 32.45 ponies. Let's go ahead and select the comfy and let's move it. And we get moving the comfy chair. Let's go ahead and select let's go ahead and select a comfy again and buy it. And we get an invalid choice. So we can't buy a comfy, but we can move it. So we can say 5 and then move. Or we can say, let's buy an and. So I want to select 3, type in buy, and I've just purchased an and. Okay, so I didn't mean to do that. Oh, come on.
Traffic gray screen in there.
Okay. So the first thing that I did was I implemented another class called chair. And I had it created another class called chair, and I had to implement IItem and IMovable. And then I provided an implementation for the move method. So far, so good. Then I create a list of items, and I add 3 chairs, or 3 cars and 2 chairs to it. Then I enter an infinite loop. And inside the infinite loop, I do a few different things. Now, the choose item, again, this does actually look a lot scarier because I'm at such a high level of zooming, but this really isn't a lot of code.
Try to lay off the scroll wheel to give people a chance to actually read it. Because
well, I'll go through things line by line.
It destroys the frame rate when you're scroll wheeling.
Okay, so we enter an infinite loop. The first thing we do is say var chosen item equals choose item, and we pass in a list of items that we can choose from. Now the choose item method, this method takes in a list of items and returns an item. And it does that by presenting the list to the user and allowing the user to select one of the items. The first thing we do is enter another infinite loop because we want to continuously loop until the user successfully selects an item. Then we'll delineate the console output a little bit with some dashes. We'll initialize an index variable to 1, and we'll continuously loop through all the items. So this part should look fairly familiar to people now. The only part that's going to be different here are these lines. Everything else, if I didn't have these lines in here, this entire thing should look very familiar to everybody here, not scary at all. Because all we're doing is we're looping through all of the items and simply giving them an index that the user can select and printing out their name. So this is no different than a lot of the other projects we've created thus far. But by adding this code right here, what we've done is we've changed the behavior of printing out every item depending on what interface it implements. So the first thing we're going to do is say, is it buyable? If it's buyable, then we want to assign it to a variable that is of type iBuyable. Now that's important. If I did not assign item to a variable of type iBuyable, I would not be able to access its price property. Notice that if I type in item.price, there is no item.price. That's because item is an iItem. Buyable is an iBuyable. They both point to the exact same object. They just have different types. They're different types of variables. So they have different members that you can access. Somebody wants a pastebin of all this stuff. I don't have a problem with that.
Except you'd rather use GitHub.
Well, of course. Okay, everybody, there is your gist, if you want to follow along while I explain things. Okay, so what we're doing here is we're checking to see if it's buyable. If it is, we're appending on a little bit of more text into the console window and also specifying its price. Then the next one was your question about the is and as K7. The reason I used as here is as does two things. Is only does one. As actually, if I wasn't using implicit typing, this is what it would look like. As not only checks to see if an item is something, but it also converts it to that something. Is only returns. So if I said, I could say if item is buyable, this would work, but then because I wouldn't have a variable, to check to see, to access the price member, then this wouldn't work.
You'd have to set up you'd have to put more code in to do it.
Yeah, it would just be
essentially
ugly.
What the as is doing for you. It's similar sort of conceptually to the difference between int.parse and try-parse. One of them, in terms of the returns and parameters, and one of them is a bool return type that tells you whether it did it as well as doing it, and one of them just tries to do it.
Yeah. Well, one of them. Well, yeah, but this as is safe. If item is not a buyable, it'll simply return null, which we proceed to check for in the next line. So now we check to see if it's buyable. If it does, we print out its price. Then we check to see if it's movable. If it does, we say can move. Then we write a new line because notice up until this point I've been just doing writes because I didn't want to append a new line. But then here on line 121, I want a new line.
Okay. Just by show of hands in the webinar, who managed to code out something that did have the same functionality as was required? Who got close? And who wants to hit Nelson with a brick right about now? Did you happen to notice who that was that said they got it right?
I forgot the name.
We should so jump to his screen and force him to prove it. Oh, where is he?
Okay.
Was it Daniel? I think it was.
All right, so let's go ahead and just finish up this method here. Then we say choose an item. We grab an index out of a console read line, check to see if it's in the bounds, and if it is in the bounds of the list, we return an item. So this all should be fairly simple by now. We're just getting some input from the user, validating it, and then returning an item out of a particular index. So line 116 could be is. Yes, this could be item is movable, but this is less performant because this actually has to do some computation to determine if this is a movable, but we already have done that computation. This is less performant than simply asking if the movable variable is null. Okay, how does everybody feel about this method? I mean, raise your hand if you are not feeling good about this method. If this method is not good, and then be sure to.
Sorry, Chris.
Now, are there any specific questions that people are having issues with this method? Any parts of it? Remember the purpose of this method. All this method does is present a list of items to the user and allows them to return an item variable from a list of items.
Well, why don't we do this? Because people are asking about a break. If you go ahead and pause the video, and then you could whiteboard out a little conceptual diagram of what's going on when you are inheriting these things and implementing other things, and the difference between what's going on. Does that sound like an idea? Or
I don't know how I would represent that graphically. That wouldn't look just like inheritance.
yeah, but just just trying to cover all bases in terms of how people could get a different perception of it. Because it's one of those things where once you see what's going on, it becomes very apparent. I was going to say, which is horrible. But yeah, do you want to go ahead and... Well, at least we can have a break, and then if there's any questions...
Yeah, I'll go ahead and pause the video. Zoom, okay, so we're resumed. We did get a few questions and a class diagram that I'm going to be taking a look at here in a moment. But we did get some questions about why can't we just do if item is iBuyable, why doesn't this work? This does not work because an item is typed to iItem. The static type of the item variable is iItem. iItem is not necessarily an iBuyable. And simply by encasing it into this if statement doesn't change the compile time type of the item variable. The item variable is an iItem, and an iItem does not have a price. Now, I could do this on IMovable. I could say if item is IMovable. This would work because I don't need to access any of the IMovable specific properties inside this line of code. The reason I broke it out like this was to make the code consistent between the iBuyable and the IMovable. So we have to. So the IMovable can be just an is, and maybe I'll just leave it here just to show the difference between is and as. But typically, I would want things to be consistent in the code. But in this case, we can't do it any other way with buyable because we need to access the buyable specific property. And as far as people getting confused, this is like the next step of programming. What we're talking about here, polymorphism, is truly the next step of programming, and it's not going to be an easy step. Not at all. But this is where we go to. We go to interfaces and classes and inheritance and all these features when we want to describe programs that have complex functionality. Now, we could, if we were using a programming language, a really simple programming language like Visual Basic 6 or COBOL or really, really basic programming language, we wouldn't even have object-oriented programming to worry about. Basically, we would have a 101 class that talked about the things we did in C#, conditionals, switches, looping, collections, all that stuff. And then that would be it. There would be no more things in the language that we could actually describe. And the rest of the classes would be, okay, you want to write this program? Well, here's how you would use these rudimentary tools to craft a 5 million line long program that asks the user for his name. But that's not what we're doing in C#. I really want people at a very early stage to get comfortable with the idea of object-oriented programming and polymorphism, because this is the fundamental, most important thing.
It's also far easier, as unbelievable as that sounds, to get to do it this way from scratch, I think, than what I've done, which was to learn a more procedural approach and then try and change my habits. Because it blinkers you to why you would do something a certain way if you do it too many times the wrong way.
Yeah, I really want people to get comfortable with this idea early on. What will happen when item is not IMovable? If item is not an IMovable, then it continues. It does not execute this if statement. Therefore, this bit of text is not printed. Is asks at runtime if the object inside of this variable, or being referenced by this variable, is convertible to an IMovable type.
There's a really good question that came in from Michael. Oh, sorry.
Does it return a bool? Yes. The is operator does return a Boolean value. Michael, I am wanting basically to know the greatest advantage of interfaces versus inheritance versus just having the members already on the class. What I'm showing here is the primary, or one of the advantages of interfaces over classes, or over inheritance, sorry. But we will be talking about a few other ways that interfaces are really nice later on. This is just not a simple example, but a complete example about one of the cool things about interfaces.
I actually meant the other, Michael. The I'm a C++ guy one.
Oh, I'm a C++ guide. So does an interface is an interface a header only? Yeah, an interface is only going to be a class inside of a header. It's not going to have any CPP file because it has no implementation.
The reason I pointed that one up is because that, when I was doing that period of transcoding some C++ stuff, is exactly how I kind of conceptualized headers files as being like an interface.
Yeah. NATO asks, why do I need to do this instead of this? Well, there's two reasons. The first reason is that I need to declare a new variable. I need a new variable. I need to store a new reference. So I cannot declare a new variable inside of an if statement. I need to declare the if statement outside of the if statement. But even if I do this, is this still not valid? And the answer is yes, it's still not valid because null, an object, is not convertible into a Boolean. Now I could do this. This would compile. Or not. This would compile, but it's ugly. It's really gross. Basically, we are performing checks at runtime because we do not know what object that item is pointing at. Item could be pointing at anything. This is the fundamental important thing to get out of this, is that during runtime, you do not know what kinds of objects are going to be instantiated. Your user might want 50 chairs and 20 cars. Your user might want 30 enemies, 1 player, 20 items, but then maybe the next time he loads the game, he wants 20 weapons sitting around the map, and you don't know at compile time what the user is going to put your program through. You need to make your program flexible. And this is all about runtime checking to see if a variable or object is of a particular type. Why not wait till you've confirmed it's viable before converting? I'm not doing a conversion here. Now this is important.
You can think in what he's doing here. You can think of the iBuyable there as being like a sticky label that is stuck on it, saying that this thing is an iBuyable. It's still an item, but it's labeled as being iBuyable when you're doing a check like this. Yes?
Yeah.
No? Yeah.
The as operator, again, the as operator will return a new variable, or not a new object, but it will type the object to the type that you ask it to, if that conversion is possible. Otherwise, it will return null. So, if item is a buyable, the buyable variable becomes the same object that item is pointing to, but typed differently to an iBuyable, so that we can, at compile time, invoke the price property getter. If item is not a buyable, what is returned here is null, meaning buyable is set to null, which means that when we check for null, this check will fail, and this code will not execute. Wick, close. It would be more like if item dot, I don't want to get into that, but if it equals type of iBuyable.
I can hear you typing, but I can't see anything happening.
It was just a BuzzNet thing. I didn't want to put that.
Oh, that confused me. I thought the screen had frozen.
Buyable is just a temp var who takes items who are iBuyable, isn't it? Yeah. I mean, you could think of it this way. Buyable is just a temporary variable that is typed to iBuyable. Now, this is the important thing. It is typed to iBuyable. And it will contain an item if the item supports that interface, if that object supports that interface.
We can show them what happens if you miss off the as IEnumerable in that line. Will that still will it compile and then throw?
Oh no. This won't even compile.
If you just right.
This.
But no, what it said at the bottom. Oh. Yeah.
This will work. This will compile, but it'll throw an exception if item is not an IEnumerable. The as operator will not throw an exception if item is unIEnumerable. What is item before, like 109? Item is still... okay.
In your for each declaration, change it. Use explicit typing. It might make it a little bit clearer.
And I didn't mean to sound like frustrated or anything. It's just that I think that busting out the whiteboard might be a good idea right now. Because this, as I'm explaining this, I realize how weird it sounds to people. Or how weird it could sound to people.
It can, yeah, it gets you spinning quite easily.
Can all types hold null? Null is a value that means that there's nothing in it. Only reference types can have a null value. Ints cannot be null. Nullable ints can be null, but we haven't talked about nullable yet.
Good job, nullable int can be nullable.
Okay, so we have, let's say we have a list of items. So a list of item. Come on, go away. We have a list of item, and it contains, let's say it contains a car. Now a car is an IEmovable and an IEnumerable. Let's say our list also contains a chair. A chair is an IEmovable. Now, inside of a for each loop, if we say IEnumerable equals item as IEnumerable, here's what's going on. If item is an IEnumerable, then these two variables point to, let's say we're pointing to the first item. These two variables point to the exact same object, this object right here, if we're on the first iteration of the loop. They point to the exact same
chunk of memory.
The difference is this is statically typed to IEnumerable and this is statically typed to IEitem. So what's going on here is that the item variable can only access the item members of iCar. So let's go ahead. I have a better idea of way to represent this right here. iCar has 3 bits to it. It has an item, a buyable, and a movable. It's important to note that these interface implementations are the same, part of the same object. They're this part of this exact same object. However, the item variable, because this item variable is typed to item, this item variable only points to this aspect of the car. Meaning we can only access members that are a part of this one aspect. The iBuyable variable, it points to the same object, but it's only allowed to access members that are an aspect of this interface. So we're getting access to different parts of the exact same object.
It's like you've got a list of checkboxes for each of your interfaces. I mean, on each of your items, and a checkbox for each interface. And you just tick off, does it fulfill the item one? Does it fulfill the buyable one? Does it fulfill the movable one? And it can be, you can use as if it fulfills the as that you're trying to assign it to.
Right. And then just to point out what does buyable can do. Item has a name. Buyable has a price and a buy method. So these members are stuffed into this aspect of the car. This member is stuffed into this aspect of the car. And when we're typing statically an object, what we're doing is we're selecting which one of these aspects of this object we want to interact with. So the item list actually stores data for something not being of a type, i.e. in the item list, it's not actually data saying chair is not buyable. So item list actually stores data for something not being of a type. In the item list, it actually has data saying chair is not iBuyable. Close. The object itself has that data. The object itself knows if it's an item, an iBuyable, or an iMovable, or not any of these, or not any of them. And we use the is and the as operators to determine, to ask the object, to query the object, hey object, do you support this aspect? Do you have members in for the item? Later, meta.
Night.
Remember, is returns a Boolean. So if I say bool is buyable equals item is buyable, what we've essentially done is we have asked the item object, the object sitting on item, if it's an iBuyable. The Boolean will be set to true if it is. The Boolean will be set to false if it is not. So basically, the is operator queries this list of interfaces that it supports. So the item list would just look like this: car, chair, and you have to evaluate those types on their own to get their properties. Yes, because the list is of type item, you have to convert the items inside of the list to another object in order to access their properties that differ from item. So are there any more questions about what's going on here? Can I do item is iBuyable and item is iMovable? Certainly. In your popcode code, you're converting every object in the items list to every possible type and taking errors into account. Yes. I'm querying the object what they really are in order to perform specific operations on them. But see, here's the great thing about this. By doing it this way, I can construct an unlimited amount of classes that have an unlimited amount of combinations of being buyable and movable, and this code will properly work. An item can be buyable and immovable. Maybe an item is neither. I mean, I could do this. I could say class, I don't know.
Giraffe.
I don't know how to spell it.
Giraffe.
G-I what?
1 R, 2 Fs. Giraffe.
I could have a
and an E.
Another E. I could have a giraffe that's neither buyable or movable, but note that it still is an I item. And if I add it to the list, and remember, the only reason I can add it to the list is because it is an I item, and run my program, notice how my giraffe shows up right here, but I can't do anything with it because it's not movable and it isn't buyable. It just has a name.
So pick 6.
So if I pick 6, nothing I type in here, if I type in move, nothing happens. If I pick 6 again and type in buy, nothing happens. Because I can't buy it or move it. It's not movable or buyable. So as tries to set the item to iBuyable, and is just asks if the item is iBuyable. Yes, that's exactly the difference.
We all want that. that segful.
Okay, are there any more questions about this method? About how this method conditionally prints out data depending on the runtime type of an object? What?
I was just going to say, I can't recall what the homework was set up to be. Is it about the state of the game?
The state of the game?
Yeah, is it?
It's not ready. We don't have a story either. But everything that we're going to be doing is applicable to the game.
I was thinking in terms of like game state dot type state, not in terms of the state of readiness.
I don't know.
Oh yeah, there we go. Somebody posted it in the question.
Yeah, we're going to be talking about state machines here in class, actually. So the homework should be easy if people pay attention to the class. Okay. Go ahead and I'm about to move on, and this stuff is really important. So if anybody is still confused about this, I really want people to understand this, because this is the fundamental concept of polymorphism, where an object can take many forms. Do you have any questions, Chris? Specific questions that I can answer? Okay, well, we are going to be moving on after this example to another example that's going to work with interfaces in a different way.
This is, although what Nelson's covered is certainly amongst fundamentals of this, he has dealt with a wide range of the topics that pertain to interfaces. If you actually strip out what we've covered in terms of the as and is and related ifs and such like. The actual, if you're still confused by the syntax and how it differs from inheritance and so forth, that's one area. It's easy to get confused and find you're mingling all these different areas of it into one big agglomeration. Or, I guess I'm just saying, take it piece by piece, go back through the examples and break down, and use the debugger to step through the program. In fact, that might even be...
I'm still waiting to actually talk about main first. I'm still on the choose product.
Oh, are you?
Yeah.
Sorry.
Okay, so let's go ahead and talk about main now. So jumping back into main, we start with instantiating a list of items. We add a bunch of items to it. Then we enter an infinite loop. So straightforward so far. We get the item from the choosEitem method, which again is the method we just discussed. We then we query the chosen item if it's a movable or a buyable, and alias out those two references into a movable and buyable reference that are typed to the corresponding interface. Then we ask the user what they want to do. We grab input from the console. And then we enter this if statement. All this if statement does is it says, if it is a movable and the input is move, well, then move it. If it's a buyable and the input is buy, then buy it. Otherwise, inform the user that they've created or asked for something invalid.
That's really quite... it's almost a paradigm for the whole of coding, a microcosm of it. Set up some stuff, ask the user which one they want to do something to and what they want to do, and then tell them they can't.
Yeah. About the choice of what do you want to do we always have to use if-else statements, or is there another way to access and list all of the functions of an object? There is something called reflection, but we're not going to be covering reflection just yet in this course. But we will get into reflection at some point. There are easier ways to represent this logic, but this is the easiest way to represent the logic without introducing maybe like another method or two. That makes this part easier.
He did.
I did?
Chris.
When you had the giraffe in there, why did you not get invalid choice when you tried to move by it? I actually did. If I ask for the giraffe and I tell it to move, it says invalid choice. If I ask for it again and tell it to buy, it says invalid choice.
Because you're not clearing the screen, you see, it's difficult to tell. Interface design.
Ah, stupid colon.
Why do you never do read be true?
Wow, another colon. I'm bad at this.
I think you might have a sticky shift key. You seem to do it a lot today, and I've never seen you do it before.
I don't know. So choose items is a list of items. No, chosen item is a specific item that was retrieved from the function or the method choosEitem. If you look at the signature of choosEitem, notice how it takes in a list of items and then returns the item that was chosen.
Please abstract the screen clearing into its own class.
Are there any questions about main?
What don't you get?
Now main, it will ask the user for a chosen item by delegating off to this method, choose item. It will then decide if the item that was chosen is a movable or a buyable. It'll then ask the user what they want to do, and then it'll say if it is a movable and the user wanted to move it, then move it. If it is a buyable and the user wanted to buy it, then buy it. Otherwise, just tell the user to go away.
I think just to round off, you should stick a breakpoint on.
Well, yeah, I can just go ahead
and step through.
Open up a breakpoint.
Because it's good. Because again, I'm drumming this into people as well. It's a good thing to do this yourself.
So
particularly if you're looking at someone else's code.
So if I jump into this for each statement, you'll notice the first item we select is a car. So then when I convert it into an iBuyable, notice how we have this price property now, and this code executes. It's also an iMovable, so we can also move it, and then we loop over and over and over again, only printing the specific things that we need to. So for example, notice how this is a chair, and we skipped over this if statement entirely. And now we're going to ask to choose an item, so let's go ahead and choose an item. That item is valid because I chose 5, so it's going to return the item, the 5th index out of the items array, or items list. It's then going to go into here, and let's say I want it to, let's say I want the comfy to move. So now it's going to say if movable is not equal to null and input equals move, which is true. See, buyable is null. Buyable is null because chosen item is a chair, and a chair is not buyable. Movable is not null because it's chair, and a chair is movable. So as a result, it returns true because movable does not equal null. And input does equal move. So as a result, we enter in line 97. So now if I go ahead and hit F11, you'll notice we jump into the move method of our chair. And then the program continues to execute.
I actually visualize it like literally like your typical image of a high school reunion where everyone's got a name label on, and like their old like school nickname on a label, and it if somebody's wearing that label, you can put them into the group. If they can't, you can't. But they're still all people. But some of them are jocks, and some of them are nerds, and some of them, and you could equally, if say you had I sports and I computing, you could also have I female, I male, and then you can have combinations of them. But it's all just labeling, really, and providing. It's saying this has certain things. Seems like a good place for a full stop.
Is there a benefit to using buyable does not equal null instead of buyable equals true? Buyable equals true is not valid. Because buyable is an iBuyable, which isn't implicitly convertible into a Boolean. So there's no way to compare it to a Boolean. Still not getting what chooseitem is doing. All chooseitem is doing is asking the user to enter. It's displaying all of the items to the user. It's then asking the user to pick an item. Then it's returning the item that the user picked. So when I hit F5, notice, actually, sorry about that. Notice how in our for each loop, look at the output that was given the user. We have each one of the items being printed out, and we also have additional information, like our stuff costs $32 and it can move. Our awesome can move. Our and costs $23 and can move, and so on. Okay, I'm going to go ahead and move on to a different example. And the example that I'm going to be showing you is going to be very similar to what the homework's going to be asking, but because of like the complexity and the shock to the system that I think that a lot of this day has caused people, we're going to go ahead and just talk about it really quickly. Because this is another very common use for interfaces.
And by this, you mean... Yay! Please make me an enum.
Ugh.
Well, actually, no, because, yes. No, yeah. You'd rather have state be a type, wouldn't you? I'm guessing, than an enum. You missed an I at initial.
Ugh, whatever. Remove. Why did I choose remove? Okay, so what I have just done is I've created a basic state machine, something that would be very appropriate for use in a text RPG. And I've used interfaces to do that. I've written a class called State Manager, entirely in terms of interfaces that it knows absolutely nothing about, as far as the implementations of these interfaces. Now I have two interfaces, iState and iCommand. An iState is the state that the application may be in. It has two responsibilities. First of all, to render itself to the screen, and second of all, to get the command that the user wants to perform. A command simply has a method on it called execute, so it's really nothing special. So let's go ahead and look at this. So let's create some states. Now I can create as many state classes as I want. So I'm going to first create a main menu state that implements iState. So as a result, the main menu state has two methods, render and get command. So let's go ahead and implement render. Not quit, I don't know. Help. And then how about load? And then I'm just going to return null for now for get command. Now I'm going to, again, once I get a few states and a few commands rendered, I'm going to go ahead and walk through this code line by line. Wait a sec, did we...
What?
Nothing. Actually, I'm going to switch this. This isn't going to take in a constructor. The iRun is going to have the initial state in it.
Makes more sense. You see, that's actually why I like to code the opposite way up to you. That's why I like to extract interfaces from a concrete.
Yeah.
You know, it's that sort of situation, because I find, you know, those are the sort of things I end up doing a lot wrong.
Yeah.
I just thought I'd point that up as you passed it.
Okay, so let's create a few other states really quickly. I'm going to create a, let's do this. Let's create a switch state command that implements ICommand. Again, I'm going to go over all of this. Actually, I'm not going to worry about this being a command, to be honest. I mean, I kind of have to, so.
Is that film with Hugh Jackman in? Somebody will know. Swordfish, that's the one.
Okay, so now we have our main menu state. Let's go ahead and create a load state. And just return null for now. That's really irrelevant up till now. And then our get command method. And again, I am going to I'm going to explain this so people don't freak out. Resharper back.
I want you to have some sort of amazing split screen technology that enables you to have every class broken out into separate CS files but still show them.
Alrighty. So now let's look at our program, and then let's go into what we're going to be talking about. I'm just doing this for example, right?
Just before.
Wait, what?
Just. Oh yeah, no. That's what I was just going to point up, because actually this is fundamentally something where I've always done it the way K73 is mentioning, but this is so much nicer.
Yes. Okay, so now I'm going to type in help, and I get my help command executed. I can type in an invalid command, I get invalid command being printed out, and I can type in load, and you'll notice I'm now looking at my load state. Okay, what's going on here is one of the really cool aspects of interfaces. What we have are two interfaces, iState and iCommand, and they really allow us to write many implementations. In fact, I'm going to go ahead and just fire up a class type. Hold on. I'm going to go ahead and just fire up a class diagram. Oh, what's Resharper complaining about? Oh, right, read only. Derp. And args and that. That's fine. And look at my class diagram. What I have here is a class diagram representing my architecture. So you'll notice that I have a variety of states and a variety of commands, and they all implement these two interfaces, iState and iCommand. So here are all of our commands. We have a help command, an invalid command, and a switch state command. Here are states. We have a main menu state and a load state. Then we have our program and our state manager. Now what I've done here is, because the way this is architected, all of these things are commands, and they can be treated like commands. They all have this execute method on them. Same thing with the state. The state interface has the get command method and the render method. Both of these states have a get command method and a render method that both do different things. So for example, the main menu state, when it renders, it shows the main menu. When the main menu state is asked for a command, it asks the user for a command and then parses the user's text and turns it into a command object. Because of polymorphism, we can pass any of these command objects, or we can instantiate any one of these classes and pass the corresponding object to whoever invoked the get command method. So let me jump back in here. So what we have here, just on a very high level, is we've categorized our classes. We've created classes with specific purposes. And the great thing is that there are whole classes that can contain and encapsulate all of the operation, all the data, and all the functionality that they may need. There might be a variety of commands. There might be in our game we'll have like pick up object command, or drop object command, or use item command, or interact with room command. So many different commands, and because we're breaking them apart into classes, we have this really nice delineation and this relatively straightforward architecture, which again, it doesn't have to seem straightforward right now, but it will, basically, is what I'm saying. So if I jump back into the code, on line, 25 through 101? Isn't that like everything? Or most of it. What we have here is, this is how this is represented in code, where we have an interface iState that has a render method for displaying output to the user, and a get command method for returning a command. Then we have a command interface that simply has a void execute method on it. It doesn't do anything really that fancy. The interface doesn't. But by saying that there must be a void execute method, we've now created a way to really cleanly delineate our classes and to make our code significantly more readable and understandable. Because ignoring the state manager for now, I'm going to go ahead and collapse it. Essentially, and the switch state command, because it's more or less an infrastructure command that doesn't do anything that's specific to the game. But if we look at...
Could you just, before you collapsing, show me, just expand switch state again, please. It's about lines 46 to 100 that I'm missing.
46 to 100?
Yeah.
Do you have them?
Hang on.
I can just paste bin this.
Okay. Okay, yeah, do that. I was building up screenshots in Paint.
Am I the only person who spams the Control-C key when copying? Okay, the link to the gist is in the BuzzNet now. Okay. So, what we have here, ignoring state machine, or state manager and switch state command, we have basically logic. But the way the logic is encoded is through the concept of objects. Each one of these classes has a specific responsibility, and we've placed the logic of that represents that responsibility into that class. Once we start getting into breaking things into the files, this way of coding is pretty much how object-oriented programming works, period. At a fundamental level, object-oriented programming is, again, about the relationships between multiple objects. We want our classes to be small, but we want to be able to find logic easier. And by actually encoding the concept of a state inside of our code and the concept of a command inside of our code, it becomes a lot easier to find code. So for example, what if I wanted to edit the help screen? What do I need to do? Well, I can expand this list right here and jump over into the help command, which for some reason is on the top. I don't know how that's sorted. Oh no, that's alphabetical. I'm stupid. Help command. And so now we have all the logic regarding to our help. What if we wanted to look at our load state? Here's our load state. Here's our main menu state.
In fact,
the return null does. This does throw an exception, by the way. I just didn't complete this method because I didn't want to type too much before explaining the architecture. What was that, Kev?
Well, I was going to say, now that you've given the gist of it, so say if people copy, they've got that to look at. If you broke it out into the correct CS files, you could actually show the name, put your abstract folder in and show that proper setup as a basic example of that.
Yeah, I mean, as far as splitting things into files, people can start to split things into files, and I really recommend that they do that.
Well, I only mentioned that because obviously you'll have to do that in order to change the name. Yeah, like that. For a discussion of keyboard shortcuts, please see the preceding video. We should totally get a commission every time we mention Resharper.
Yeah. Okay, so what we have here is in our Solution Explorer, we have the code.
Actually, that is one thing that you didn't actually give the keyboard shortcut to in the earlier video, which is the automatic breaking out of everything into its own.
Oh, you just select a code file, hit Control-Shift-R, and then say Move Types into Matching Files. And then hit Enter.
Thank you.
Okay, so what we have here is hopefully, yeah, but only with Resharper. Hopefully this is starting to look a little bit nicer. Now that we have our code separated out into multiple files where each class has its own file, every file has a purpose. Every class has a specific purpose. And finding a particular piece of code becomes trivial now that we've encoded the concept of commands and states into it. And we've done this by using the command and state interfaces, which are really small, but they're deceptively small because they have very large implications.
And I've actually just physically relaxed at the fact that you're now looking at 9 lines of code, 14 lines of code, 21 lines of code. Not line 109, please. It makes... It's like when you have an inbox. I used to do a job where I had, reams of paper coming in, and I'd start off the year with no concept that I was getting anything done, because no matter how much I did in a day, it never made a dent in the amount of... And it's the same with code. When you've got a wall of code in front of you, it just... your eyes wander on it. You can't help it. It's intimidating and it's complex to look at. Here you've got the added sort of graphical benefit. You can look at the Solution Explorer and see how it relates to the code hierarchy that Nelson was showing. Or hopefully.
Yeah. Okay, so now that I've thoroughly confused everybody, let's look into how this code actually works. At the heart of this program is the State Manager. The State Manager class is the engine, I guess you could say. all the state manager class does is it keeps a reference to the current state that's active. It provides a method to switch the current state to a new state. And then it has a method called run. And the run method contains an infinite loop that will continuously execute. Well, in this case, indefinitely, there is no exit condition. The run method also takes in an iState for the initial state. So it takes in the first state that's going to be used.
Wick just asked in BuzzNet, should there be an interfaces folder in the Solution Explorer?
I use an abstract folder, or an abstract namespace. I like this convention because it lets me, because abstract starts with an A, and it's sorts really nicely, and it's a way to easily, looking at the interfaces of code should give you a good idea, a good feeling for the code. So I like separating it out. I really don't like seeing code where the interfaces are mixed with the concrete classes.
Well, and also, I was kind of focusing more on the fact that you've named it abstract, which, although it works for sorting very well, is also down to the fact that it does drive home again the point that if interfaces are by nature abstract.
Yeah. So here's what people should be getting out of this example. With a little bit of work with interfaces, we've created a very generic engine class for our program. And this engine class, all it does is it renders the current state, it asks the current state for a command, and then it executes that command. So it's really simple right now. And that's really it. That is the framework of our code. Now, if we look at the main menu state, notice some things about it. First of all, it implements iState because it has to, because it's a state. It takes in a state manager as a constructor parameter. And the reason it does is because main menu state needs to be able to tell the state manager to move to another state. Almost all the states will take in a state manager. The render method simply renders the main menu. In this case, load and help. The get command method, all this does is reads input from the console, checks to see if it's a load operation, and if it is, it issues a switch state command to a new load state. If it's a help command, it returns a new help command.
Now, actually, would...
You what?
Sorry. I was going to say, actually, because I know I was saying how this is a better system for states than enums, but actually, would command, in this case, be a good candidate for an enum?
I wouldn't.
Would you not?
Nope, because commands allow us to have code in them. And basically, we have two options with commands. We could...
Oh, okay. Would you, or instead a property of command type, for instance, that is an enum?
I still probably wouldn't, just because there's no need to. You should only have to invoke the execute method.
Fair enough.
So can we use the manager to go back to main menu? Yes, but we're going to have to pass stuff into the load state. We're going to need to pass in the manager to the load state, and we're going to have to pass in ourself to the load state, so that the load state will have enough information to be able to jump back to us. So if I go into the load state and add a constructor that takes in a state manager and an iState last state, its render method could say something like go back a screen, and then the get commands method could be var input equals console.readline. If input equals back, then simply return a new switch state command, pass in the manager, and then pass in the last state. So whoever instantiated the load state will pass in itself so we can go back. So then, instead of returning null here, I'm simply going to return a new invalid command. So now when I run the program, you'll notice that I can type in load, and then when I'm in load state, I can type in back and jump back into the main menu. Then I can go in load, back, help, load, back. So I'm transitioning between these different screens. So I'm going to the load screen, the help screen, the back screen, the new game screen, the investigate room screen, the inventory screen, the item screen. And then I'm issuing commands like move forward a room, move back a room, open up my inventory, or attack this person, or and so on and so on. Why not use a switch statement for different commands? Because that switch statement will become ungodly large. Wow, that doesn't work. It would become very large, basically.
Unholily?
Unholily? Yes, I guess. The switch statement would become very big. The whole point of this isn't that you can't do this without interfaces or classes. You can do this without interfaces or classes. You could write a program that does exactly what this program does with everything that you learned up to week 4 in the 101 class.
You've got Resharper on there. You could inline all your methods.
Yeah.
Put it all back into main.
You can do this exact same code, or not this exact same code, but the exact same logic without much advanced features. The problem is that your code is going to get ridiculously large and unwieldy. The entire point of object-oriented programming is what we're doing here. We're separating out the concerns of different operations into their own objects so that we can easily navigate our objects, and we can easily reuse our objects, and we can easily change them. Yeah, all main is that. Oh, you meant instead of the if statements for each state? Here, I'll leave main up. Let me go ahead and dock this over to the right. Yes, I could have used a switch here, but I was using if statements instead. Yep, loadstate.cs is just going to be when it gets rendered, well, when it gets instantiated, it gets a state manager and a reference to the last state that was active before the load state was active. Then the render method simply prints out the user interface, and the get command method simply says if they typed in back, switch back to the last state that we were using. How do we know how to add without Resharper line 2? Without Resharper, Visual Studio 2010 will give you this little thingy right here that you can activate with the Control-Dot keyboard shortcut. The Control-Dot keyboard shortcut. So this one down here, this up here, this is a Resharper feature. This down here is a Visual Studio feature.
Sometimes getting that to pop up can be quite fiddly because you have to be right on the beginning corner of it. Have you got the blue? Have you got anywhere where it's got the little blue one character highlight?
Well, yeah, like right here. It's right down there.
Yeah, you have to be right on that highlight to get that pop to appear.
The only reason I'm using Resharper my Visual Studio instance right now is I wanted to split everything into files. Alright, so before we take a quick break and let people sort of soak in everything and ask questions, on a scale to 0 to 10, how good is everyone feeling about this? Or how bad? Wait, so we have to choose as positive or negative?
Basically, put your hands up if you're still monumentally confused. And your name isn't Slim Shady. Okay, put your hands up now if you're moderately confused. Okay, who's feeling lead? write those down. Excellent. And who has died about an hour and a half ago? Well, that's not bad.
Yeah, this video is a lot to take in, basically.
Well, this is, I mean, yeah, this is why it ended up getting split across 2 weeks, because it really isn't something that you can compress and then say, oh, well, if you try and pick it up as you go along. It really is something fundamental to certainly the way Nelson approaches programming, and it's a very, very sensible way to approach. And I mean programming as a whole, abstract concept of starting with a blank page and how do you build a program to do anything.
Well, as far as what Wick said, basically, if you look at this, there are millions of ways to write code. And the more tools that you get, the more ways there are to write code. So the more language tools that you get, the more ways that you can express yourself. C# has a lot of tools in it, a lot of different ways of expression. Now, there are a lot of ways to make a program that does what this does. Lots of ways. Even ways that people here would be comfortable writing within like an hour or so. Or less than that even. The point is what I want people to notice about this solution, and what I want people to start thinking in terms of, is that we've broken the responsibility of our code into granular steps that are easily navigatable. We can easily identify the commands that our program supports. We can easily identify the states that our program supports. None of these classes are very big, and they all do a specific thing. The more this is true, the easier it is to continue to... You what?
No, I thought you'd finished, but you haven't.
Yeah, we kind of did go from 0 to 100. But
well, let me give you. There still might be people who are unclear on why this would be a better approach. So let me play client a minute. Okay. So you've made me this amazing state machine app that I've had for a while now, and I've come back to you and said, look, the guys in the office are coming to me all the time with all these complaints about it. There absolutely has to be red lettering on a green background. Oh, and we need to be able to save state as well.
Right.
Why can't we do this? I need this done tomorrow. Then I go away, you kick the dog, and then you sit down at your computer. What happens?
Well, yeah, I mean, you in that case, if you look at this architecture, you would just create another state.
Sure.
I was about to hit Alt Insert. So I'm going to create a new class called SaveState. And the SaveState is going to implement iState. So it's going to have a render method and a get command method. The render method, again, we're just going to have like a console write line, blah, 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 blah. Save state. Now everybody pretend there's a bunch of interesting functionality in this.
Have a cookie radioactive, but active pretending. Wow, look at how he's saving that state. It's revolutionary. See, we've been very generous to people today with these two gifting out the code. So I think when you've done type, I think you can let people type these two out, and we'll have a break while they do that.
So now I can type in save, and I get into my save state, and I can go back to my main state. Now I can go into my load state, and I can go back to the main state. And I can go into my help command, which doesn't change the state, just prints out help.
The key point with that being, it's far easier doing that than it would be routing through.
Well, yeah, think about it this way. How much code did I modify? I'll give you a hint. I added 3 lines of code to existing code. The rest of all and this. So I modified the user interface and I added 3 lines of code. And again, this doesn't need to be 3 lines of code. This could be 2 lines of code. And it actually isn't 3 lines of code, it's 4 lines of code. So actually I added 5 lines of code basically. Anyway, the point is, by separating things out by interfaces and hiding our implementation behind interfaces, we were able to add a significant portion of functionality to our code without modifying much. The only bit that we had to modify was we had to make the main menu state aware of the new bit of code. But main menu state doesn't care how the save state works. It doesn't care at all. The save state is free to have as much code as it wants in order to perform its action, and it's not going to bother anybody else.
Hence the term interface.
Right.
As Wix saying, "Oh no, it was hiding." Yeah, you're providing an interface in the proper English sense of the word. So do you want to leave them with something to ponder over
Yeah, I can go ahead and...
You mentioned taking a break.
I can go ahead and show the save state, which I added, and then the main menu state. So this is the code that I added. And I do want to point out really quickly, though, that doing this, practicing this, is the only way to learn object-oriented programming.
Well, here we go. I'll give them the puzzle. Get them to implement the other client demand that I made.
What was it?
Colored screens.
Yeah, if you guys want to change the... With this code, you can easily go in and change how everything is rendered without... doing stuff. I need a cigarette.
Oh. Have you paused?
Okay, we're back.
Yay!
Yay.
Woo. So yeah, basically, implementation is great.
Yeah, well, interface implementation is great. Interfaces themselves are great. But yeah, so what we have here, and you guys have seen the code, and the homework is going to be pretty much replicating this and adding a few new features. So I just want to point out again to people who are watching the video and aren't here and didn't hear the discussion during the break, the entire theme of this class is code like this. It's not going to get terribly much more complicated than this. But the problem is there's not much, there aren't very many ways to lead up to this, to actually have something that's useful. Because although people might not understand the whys behind how things are being done at the moment, this is a useful example of object orientation, an actual useful production-ready example. And this was the easiest one that I found for building out an RPG game.
Why do you think I wanted? Why do you think I was taking all those screenshots?
Okay, can you explain how an interface is a return type? Yeah. So on our get command method, our get command returns an I command, meaning it can return any class. It can return an instantiation of any class that implements I command. So it can return an invalid command, or a switch state command, or a help command. Or it can return another class that we don't have yet that does something else. And it can return any of them. And the reason why this code works is in our state manager, we get the command from the state, and then we just turn around and execute it.
Part of that will be probably because in nearly everything you've done, although we've sort of touched on collections a little bit, you'll have had return types, if you've had them, of things like int or string or various other keywords that will be all sort of blue and lowercase. And some people might be finding it a little confusing that all of a sudden there's this thing that we're using as a return type. It's still a type. Although it's an interface, well, this is the point where I would rather Nelson continue my sentence for me, just to make sure I don't say it wrong.
Well, yeah, iCommand is a type, and it's a type that can be returned and used as a variable. And so therefore, we can return any type that's convertible into the interface, which is going to be any class that implements the iCommand. Any class that's tagged as an iCommand can be instantiated and returned from this method.
Does does IntelliSense prompt you to use base types? Or
Well, that's Resharper.
Oh, if you've got Resharper, you'll find you will have come across this already, I guarantee, because if you return a list type, it will tell you that you can return usually an IEnumerable, but sometimes an I thingamajigable.
Yeah.
Collection or something. And that's what's happening there. It's basically saying, look, I can provide this functionality over a wider range of things perfectly legally if you let me do it at a higher level in the hierarchy.
Right. Like, for example, if the get command method returned a invalid, or let's say it returned a help command, this is not useful. This method is pointless. This method does nothing special because it only returns a help command. We need to do a lot more in our RPG than simply ask for help all the time. So
if you actually look at the get command, the actually implemented one, and imagine that return type on it of help command, most of what's in there goes away. You simply can't do it because you're not, it's not a load command, it's not a save command, it's not an invalid command, it's just a help command.
Right.
It's only because the return type is iCommand that you get to do any of that.
Gavin, was that, or NATO, was that an okay, or?
I think he turned into a librarian.
Oh. What I thought I understood has now evaporated.
I have that effect on people.
Basically, the get command method returns any object that is an iCommand. Any object that can be converted into iCommand. Which could be an invalid command, a help command, or a switch state command. Because those are the only three classes that we have that implement iCommand.
Can you easily show him the list, like I was talking about? What happens with the list?
Well, yeah. So if we have a program, Ken, I'll actually talk about that in a second, but I do want to point this out. Show items, list of ints. Okay, so what we have here is a method that takes a list of integers called, and the parameter name is ints, and then all it does is it uses a for each loop to iterate over them and present them to the user. But Resharper is telling us, wait a sec, you're asking for a list, but list actually implements IEnumerable event. Now, we will be talking about the IEnumerable interface at the end of this course, but basically, any object that can be used in a for each loop is an IEnumerable. So an array is an IEnumerable and a list is not an IEnumerable. By changing the type of this parameter from a list into an IEnumerable, we've essentially broadened the amount of things that we can pass into the showItems method. We can pass in anything that implements IEnumerable event. We can pass in an array.
That's exactly.
Yeah.
And that's exactly equivalent to what he was doing, where he was saying, if it returns a help command, that's not particularly useful. It can actually have more useful behavior if it returns the base type, and that's the sort of buzzword that you'll hear in relation to this, which is base type, the parent essentially.
So it returns only things that have implemented the iCommand interface and have an execute method that's defined? Yes. This can return any object that implements iCommand. As far as return new invalid command, the reason I'm returning a new invalid command is I'm instantiating the invalid command class into an object. So basically I'm doing this.
Could you not use the base type?
I could, but I just wanted to point this out.
I was just thinking, ironically, that could be a...
So the invalid command, I'm instantiating it, and then I'm returning it from this method. Because I want a new invalid command. So what you're returning is an object, not a class. Exactly. We're not returning a class, we're returning an object that is an instantiation of a class.
Well, it's very much, what is a class?
Well, class is just a, it's just a template for an object.
Yeah. And you know, it's a blueprint for an object. You don't want a blueprint of a house, you want a house. So you use new house.
Right. So we need to instantiate an invalid command. So then we're passing the instantiated object back to the state manager. Does that make sense, Ken? All right. Okay.
Scope. What is a pocket definition of scope?
Well, every variable has a scope. Well,
everything.
Think about curlies. A curly defines a new scope, generally speaking, and things inside of a particular curly set are only generally accessible from things in a lower version. That wasn't his point. Okay. Okay, I do want to move on from this because we have some BCL things to talk about today.
Ooh,
and then we're going to talk about the homework. But I really want to stress this for people who are confused, who don't understand how things are coming together. Write this code out. You have all of the code in that paste bin that I sent, and you have all of the code being written on screen.
Do you want to make that gist available to people via the site, or is you... I'm in two minds, because I personally think that people who have sat through this much of the video deserve a bonus compared to people who are just going to skim through it at a later date.
I don't mind. I mean, people who are watching this in the video can pause. People who are here
they can rewind and take the screenshots. I think the people who are here deserve the gist, just for being awake and nice to us.
Yep.
I'm feeling very, very magnanimous at the moment.
But yes, anyway, I just want to reiterate this one more time. This code that we're seeing here is the epitome of the complexity that we're going to be dealing with the entire 102 course. If you don't know this, if you do not completely understand this code right now, the first absolute thing that I recommend is to write it out and watch the video and go into the open office hours. Because if you get over to... If you can get past this, which everybody here can, then that's object-oriented programming. then we can start...
Yeah, and it doesn't get any more complicated. It just gets longer.
Yeah, and then, I mean...
You just have more of this. that came out sounding bad. It was meant to sound encouraging. What I mean is, it doesn't get any more complicated than this. It's just this in a lot of different permutations, really.
Right. And like, for example, like the code inside of a method might get more complex once, you know, we're inevitably going to go over link, you know, in the 103 or 104 or 201 class. So
no, it's got to be 103. You should make 103 all about link.
Yeah. So we'll get into link, and the stuff inside of the methods might get a little bit more complex as we learn more tools. But C#, this is C#. C# is all about classes, all about interfaces, all about object-oriented programming.
And you touched on something earlier, but it wasn't the point you were making, so I didn't mention it at the time. When you were talking about old-fashioned languages, BASIC, and the good old days of tiny little green screens, and having to number your own lines, and go to, as Radioactive says, that is still what is going on.
Yeah, we organized it differently.
That is what your program is doing. It is still doing that. But modern programming languages, C# in particular, .NET languages, it provides ways of helping you do that. And I mean, it hadn't occurred to me until actually sitting through these that to think of like an order of complexity of loops. So how do you make a for loop only using a while loop? How do you know?
Yeah. And how do you make a for each loop only using a while loop as well? And, you know, it's just a level of abstraction.
It is, and there's parallels in, you know, certainly in logic, you know, it's standard practice to make everything out of ors and ands, and nots. You can make everything out of those three, which is why those are the only ones you have in C#, I would imagine. But I'm starting to waffle, so I'll stop.
Okay, I'll answer one more question, then we really got to move on to the BCL stuff. Can you show how you did the back again? Yeah, basically my load state takes in two parameters in the constructor. The state manager class, or object, and the iState object that represents the last state that was active before the load state became active. Then what I do is I take these two parameters and I turn them into fields, and I just store them as private fields. Then in my get command method, I check to see if the input is back. If the input is back, then I return a new switch state command, and I pass in the last state that was active in order to get the last state to become active again. So in the main menu state, we've been going on for 4 hours, but the recording's only been for 3 hours. I just want to point that out. The main menu state, when we instantiate a switch state to the load state, we pass in this into the load state's constructor, which informs the load state that when we go back, to switch back to making the main menu state active again. Okay.
Just deep breaths, NATO. In actual fact, this is, yeah, wipe your, you know, deep breaths and calm because we're moving on to something a little, if not easier, differently intense.
Yeah, and you know these classes are actually pretty difficult. I feel kind of bad as sometimes, but I know that this is how you get to, I mean, this is just how it works.
At the end of the day, I look back on, I spent at least 2 years coding very much in a procedural fashion. I mean, you've seen some of my early code,
yeah,
Nelson, and it's quite scarily horrible. But it got the job done. And I think in a certain, there's good and bad about that. There's a good way in that, like we did with the 101 course, it makes you think about the basics. But when it comes down to it, when you can wrap your head around this way of doing things, life becomes so much more straightforward and logical. But Oh, sorry, I got distracted by a question there. Tell him no. No more gists.
Yeah. I downloaded Qt for multi-platform. Can I use C# in it? If you can get the Qt wrappers for C# to work, tell me how, please.
This is Nelson's. You really don't want to try that tone of voice.
Yeah, they basically they used LVVM, which is a virtual machine thingy that takes native code and makes it's this whole thing that really just if you can get Qt to work in C#, let me know how.
We're going to have to move on, aren't we?
Yeah. Okay, so is everybody ready for some easy stuff?
Link!
Yeah. So today we're going to be talking about generics and reflection and dynamic IL code compilation.
Stop it. Nelson, you'll kill NATO. It's the way to Bewick.
Yeah.
To Bewick? That sounds like it's in Scotland. Right.
Okay, so
BCL, what does that stand for?
Oh, BCL stands for the base class library, which is
what?
The base class library. It's a collection of classes and stuff, just classes, interfaces,
It's a
structures.
library of classes.
Yeah, it's a library of classes and interfaces and structures and all that stuff that give us some really awesome built-in functionality. It's similar to C++'s STL. It's actually more like C++'s standard library. And the STL is underneath the standard library of C++. The BCL is basically the standardized standard library for C#. Almost everything underneath the system namespace is a part of the BCL. Not everything, but almost all.
And to anyone who's used to C++, this is where you get to say goodbye to import woes.
Yeah.
Import string, for goodness sake.
Okay, so let's just quickly go through these, because these are really simple. We have file info, directory and file. So we have our file info class, our directory info class, our directory class, and our file class. And they're all very straightforward. Let's talk about our directory info.
Are they all going to throw an error at the moment?
Huh?
I said, are they all going to throw an error at the moment?
No, they shouldn't. I hope they don't.
Yes, they should.
Well, yeah, because they're not imported yet, but...
Indeed.
That's what you're referring to? Because I was going to...
That's what I was
Well, I was going to go over that.
Well, you know, I was doing Jason. I was being...
You were doing Jason.
Leading question. Not in that way. Carry on.
Okay.
Slack.
So let's go ahead and... okay, so all of these classes are underneath the system.io namespace. The system.io namespace contains a variety of input and output classes for us to use. Okay, so let's talk about the directory info class. The directory info class, not surprisingly, provides information about a directory on our hard drive. What can we do with the directory info? We can do a lot of stuff. We can ask if it exists. We can get attributes from it. We can get its creation time. We can delete it. We can enumerate its directories and its files. We can get its files in the form of file infos. And yeah, we can do a whole lot of stuff. We can move it. We have a name. We can get its name. We can get its parent. We can refresh the information on it. And yeah.
And I just want to ram this home yet another time. Get used to typing something in, hitting the dot, and seeing what is in the list. Take the time, the first time you use something, to go down that list and just have a look what's on it. You'll get used, because you will see variations on themes occurring again and again and again. You know, at the most base level, everything's got a toString. But, you know, there'll be a lot of create methods. There'll be a lot of count or length methods, properties. You know, there'll be certain things that you'll start to recognize coming up. And all of this, again, will familiarize yourself with the kind of shapes you expect to see. It's like recognizing a silhouette of a human being. You start to recognize the silhouette of what a for loop should look like, of what a switch statement should look like, without having to look at detail at every single thing to see what it's doing.
Yep. So let's go ahead and I'm just going to use one of the methods here because, again, this is class, like I said, and if anybody thinks this is, if anybody doesn't understand what this class does, then you can ask. But really, this class does whatever's in its member list. Okay, so so we have this method called getFiles. GetFiles returns a array of file infos. And what do file infos let us do? File infos allow us to get information about files. We can do things like get the last write time, get the last access time. If it's read-only, we can get the length of the file. So let's go ahead and just do something interesting. I can go ahead and say console write line, file name, file size. So info.name, info.length. And hey, what do we get? We get all the files on my C drive and their length in bytes.
What? No ponies?
And this is my VM. I only use my VM for work. Is anybody curious about this code? Because this...
Are those sorry, length in bytes, yes.
Yep.
No.
So let's go ahead and print out all of the child directories.
I find the terminology quite confusing with this, if I'm perfectly frank. But I think that's probably because I'm too much of a grammar Nazi.
What do you mean?
It's just the whole directory info thing. It's a bit... feels like they really wanted to put a partial directory class together.
Yeah.
You know what I mean?
Well, there is a directory class.
But it feels like a partial to that, if you know what I mean. There's a lot of things where I would expect to find them in directory where they're actually in directory info.
Right. So here we go. Here are all of my files and all of my directories, and I can do a bit better in that formatting. So in C# and in most in all .NET languages, this is how you list, or this is one way that we can list files and directories. Does everybody feel good about being able to list files and directories? Okay. So we have all of these file info, and directory info and file info classes. And again, if you want to know more about these, just look at the dot. Look at the members. Okay.
The number of ways in which Visual Studio will try and help you, even without Resharper, are probably NaN.
Or probably what?
They're probably a big integer. It tries to help you if you let it. So let it help you. Use debug. Use breakpoints. Use F1 to MSDN.
Yep.
And then use Bing inside it because they force you to. But anyway.
Okay, so we have our file info and directory info classes. Straightforward, awesome stuff. Another thing that we can do is as far as the...
Actually, sorry, just before you carry on with that, because Dunn said use Google to MSDN. The key thing with using F1, and actually I don't think this has been pointed out on video, is if you select something and then search the help file, it'll take you to it.
Alrighty.
Get used to using that. It is incredibly helpful.
Okay, so as far as these for each loops, the getFiles method returns an array of file infos. Now, a for each loop lets us loop over all of the items inside of any collection. So we can loop over all of the items inside the file info array. So you'll notice that it does return a file info because the return type is a file info and then bracket bracket, which indicates that this is an array. It means it's going to return 0 to many file infos. By sticking it in a for each loop, the for each loop is going to loop for every item inside of this array and then print it out to the screen. Okay, so that's directory info and file info. We also have a directory. So let's go ahead and say directory is basically everything, almost everything on the directory info class is available on directory, but directory is a static class. So if we don't want to go through the trouble of instantiating a directory info, we can simply say directory.exists. We can say if not directory.exists test, then directory.create correct directory test. Now if I run this program and locate the project on my physical hard drive, you'll notice that a test folder appeared. Very straightforward. File allows us to do a variety of things. We can copy files, we can create files, we can even decrypt files. We can delete files, encrypt files.
You can what?
Wait, what?
You can decrypt files.
Yeah, decrypt.
Cool. Show us.
And encrypt.
Ooh, show us.
Well, if I go ahead and create a test file, or a test.txt file, and run this, now you'll see test.txt is encrypted. Which, because Windows 7 this uses the Windows 7 encryption, meaning I can still open this up and use it in Notepad because Windows 7 actually handles this for us. But
well, you're the owner, presumably, of that file.
You what? Yeah, because I'm the owner.
Presumably, you're the owner of that file. Yeah.
And you notice that save the encryption key popped up, back up my file encryption key, and you'll notice it's encrypted because it's green.
So where's the key?
I don't know, somewhere in Windows.
Right, okay.
I mean, I can back it up.
So how do you... Oh, wow. Man, I've got to spend some time digging around in these. Sorry, I shouldn't be distracting you, but that's cool.
And we should not have to close them, right? Yeah, almost none of the things from the... Well, actually, no. If we do file.open, for example, and pass in a path, and let's say a file mode of... open or create, what we'll get back is a file stream. And the file stream must be closed because we're actually getting a stream. But anyway, so file is just another thing that we can do. There's really no real examples that I can think of because, well, I mean, if we want to delete a file, file.delete. If we wanted to rename a file, or if we wanted to, you don't rename files, you move them. So if we wanted to rename test.txt to test2.txt, I can simply hit F5, and now if I jump back into the folder, notice how it's renamed.
I mean, if you really want an example, I could chuck you the code for the Dropbox, for the file manager I did today.
Yeah, how you loop over
horrible spaghetti code.
Well, yeah, it was something like you have like a list of users,
Which one are you thinking of? The parser, the email parser?
I think so.
Hang on, I can send it to you if you'd like. I mean, there's nothing top secret in it, is there?
So then let's go ahead and create a thing called user / week 1, then pass in user, and then pass in, I guess that'll, and then we can do for_var I = 0, I smaller than 5, I++, and then we can say create directory week 2, and then pass in I. And so now I go ahead and hit F5, and I get an exception because I can no longer move that file that I deleted.
Funnily enough, what with it not being there and all.
Yeah. Oops.
Actually, this does bring up another point, which is that I would say probably more of the actual physical, well, not physical, but spatial lines of code are spent checking that you're not doing something dumb than there are when you actually spend doing what you intend to do. Would you say that's a fair assessment?
Yeah, a lot of code is testing. That's why unit testing is so important. But we're not touching on unit testing.
No, what I mean is literally in code, you're doing like all your for eaches and fors and ifs, and at the end of the day, what they come down to is narrowing down a condition. And you spend more time doing that than you do actually printing something to the screen or updating than, you know. How far can I go back to learn C# and 3D Buzz? If you, well, you're here, so you're a member sponsor. That means you've got access to everything. Pretty much everything in the back catalogue is available, apart from maybe a couple of things.
Yeah, like the math stuff. All the stuff done by Steve Twist, I believe.
Yeah, it's basically, he was an independent producer, so his stuff is slightly different. But certainly, I mean, all the C# XNA 101, I mean, volume 1 of XNA 101 is all C#. And actually, if you're lacking in, or rather, if you're not lacking in free time, zoom through those videos, and you'll probably amaze yourself at how much you've already picked up from these videos, because you'll see things and go, oh yeah, no, I recognize that. But also, I mean, it will give you a different perspective on coding, which might make some of these examples seem... I think that's part of the problem. I really, having done it the other way, for me, I would have preferred to have learnt straight from Nelson straight away. But that's just because once I know a way of doing things, I'm incredibly set in my ways, and I find it very difficult to change how I do things. So I'd rather learn it this way in the first place. That said, there are probably a lot of people who will find this way of doing things a lot less confusing if they run through certainly volume 1 of XNA. And even if you don't run through the whole thing, actually go through the knowledge reviews that are in XNA. There's about 7 or 8 knowledge reviews, which are little programs to program, little projects. And don't do knowledge review 7 first, because it's evil and everyone hates it.
I still need to watch that.
But this is the ironic thing. I think probably I must go back and try it, because with this approach, it would probably be a 5-minute job. Knowledge Review 7, for those of you who don't know, is legendary in amongst the realms of 3D Buzz. Just search the forums.
Okay, so are there any questions about file info? I really quickly want to talk about homework and end the video so that I can get to encoding them, because I think we've covered everything we wanted to cover today. So any more questions about file info, directory info, going.
Wented.
Okay. You know, that sounds dirty. Or is it just me?
No, that's just you and your ponies. Anywho.
Okay, the homework.
Homework! Hurrah!
Homework. What I want to see people do is, and I've said this, I've alluded towards this, but I really want to see people do this. I want people to create the state machine. Can use what was gone over in the video. As in, you can use the state machine implementation that we went over in the video. Then I want these states: a main menu state, a load file state, and a new game state, and a help state. Actually, I don't really want a help state. I want a help command, because it doesn't really need to be a state.
No save state? If you're going to load, you really ought to. It's not like it's any harder.
Yeah.
Go on. Is there a particular reason you didn't want
to? No, sorry, Jason just texted me. And I was thrown off for a second. Okay, so we have a load file state, a save file state, new game state, and help command. Okay, here's what I want the behavior of these states to do. I want the save file state to ask you for a file name and to save an empty text file given the provided name. For the load file state, I want to allow the user to choose a file. And for all of these states, allow the user to return to the main menu.
And validation, file-wise, before people start destroying their hard drives.
This will allow the user to choose a file given a list of files. It'll simply enumerate all the files of a particular extension from a directory. It'll just show you a list of files that have a specific extension, and you can choose what extension you want.
.gav, if anyone's looking for bonus points.
Okay, so these are the states that I want. Here are the commands. I want a help command, a load file command, a save file command, and a new game command. Now, I want to point out that new game will be a dead end, because there, well, isn't a game.
Give them a console write line to put in there to show that it's... So put that in there so that we can see that something's happening.
Yep. Now, you are not restricted to any of these amounts of commands or states. I just want to see these ones in particular. Obviously, you'll also need, for the commands, you'll need like a switch state command. But again, the implementation of the state machine is up to you guys. That being said, a lot of you guys, and you're more than welcome to, in fact, encouraged to, use the one from the video and type it out, especially if you don't understand it already. Yeah, you can use as many classes as you want.
Some short discussion would be necessary, well, certainly helpful at this point, about the game. We haven't talked about this at all. I mean, we've made reference to Hyperion, but we haven't actually talked about the game at all.
Nope.
So perhaps we should probably do that, so that people know what sort of things to come up with for their games, start them thinking about it.
Yeah, well, the problem is the story hasn't been developed yet. All the features haven't been finalized yet.
No. People should be doing their own stories.
Yeah, and as far as the game goes, but
who in the class is old enough to, or retro enough to remember playing Segfault? Yeah, there we go, Zork. actually not many. Oh no, here we go. We're getting a few more. These are the games back in the days when, you know, anything that you actually physically outputted from the computer was on green and white striped paper with holes in the sides. And this is how games used to be. You used to have to guess what things were called. And Hitchhiker's Guide to the Galaxy for the win. The hardest game ever made. Graphics aren't everything. And it's too easy nowadays. The graphics have become everything in AAA titles. Gameplay was where it was at back in the days when famously the space shuttle went to the moon on less computing power than a pocket calculator. You could have a fantastic game that had appalling graphics because the gameplay was excellent. Sorry, I've gone all philosophical again. But what I mean is you need to explain a bit about what you expect this game to turn out like.
Yeah, like Zork.
How does a text adventure work?
It's a text adventure.
Yeah. Okay. I'll click on that link in Wiki Nelsonpedia. Nellypedia. There we go. I'll click on that Nellypedia link and ask for disambiguation, which is a horrible word which shouldn't exist.
Well, here.
Oh no, it's fine, right.
Okay, well...
Oh, how embarrassing. I just made myself laugh very loudly. Did you read that error?
An error? No.
You got an error. Did you read it?
Slightly nauseating exception caught. Unable to fit through the window. The console can't run this.
It's because of your screen resolution. But I'd completely forgotten I'd done that. Sorry.
Okay, but anyway, so here is a text adventure. It's literally an adventure game
without pictures.
How do I go back to the room description?
Look, I think.
There we go. So this is basically what we're going for.
In fact, this will probably have formatting problems, but if you stop it and then run it again and then just do load. Now do stairs. And then map. Oh yeah, it's because it's not big enough, you see. You broke my map.
Okay, but that is what we're going for. But any more questions about this homework?
How to go about saving safely, I suppose, would be actually quite an important thing to...
Well, you can just... basically, all I want is to save an empty text file, so just do file.create. If not file exists, is worth... Just make sure it isn't there and you're overwriting something horrible. Actually, it could be even...
Do you mean confirm override? Yes, no checkbox type thing.
Yeah.
Not checkbox, you know what I mean.
Dave, to an extent, we did cover a bit of week 4, but that was the example of inheritance. I already went over. I mean, basically, this between last week and this week, this is the material we're going to be covering over these weeks. But we're going to be talking more in depth about interfaces, design discussions, and different ways to use interfaces. So, and other object-oriented features.
Aside from just the fact that a concrete example worked through is far more useful than abstract definitions of what an interface is and what and even like the examples we've done so far, it's a catch-22 really. You need a sufficiently complicated example to see the benefits of doing things this way, but consequently there's that sort of steep learning curve to them. You've just got to sort of hold your breath and dive in.
Okay, well, I think we're about to head off.
You posted that into Skype for me.
Yeah.
Cool. Thank you. And presumably we'll have an office hours next week, will we?
Yep.
Before the class? Like, will it?
Yeah. Alrighty. So, yeah, that was a great class. So...
Yeah, that's what I was wondering about, what Ken just said.
Yeah, I'll try to do it on Wednesday tomorrow. I'm sure that'll be fine. I only have one thing scheduled on Wednesday, which lasts until like 3 to 4 my time. So the earliest of the open office hours, if we do it Wednesday, would be when we started class today.
It does enable people who are struggling to still get their homework in on time, and I'm totally with that, Ken. We'll certainly work to try and get that to happen. And of course, due date will be the start of this class next week.
Alrighty. Well, sweet. I guess that's it. So, goodbye.
Well, well done.
I'm just going to stop recording.
Well done for 2 sessions in a row.
You what?
I said well done for 2 sessions in a row.
Yeah.